the first thing we need to do is get Ruby and wget. So actually, we don't need wget. We can just use curl. And I just don't know if Ruby's already on here. No, there's no Ruby. So we're going to do sudo yum install ruby-y, so we don't have to press Y to anything. And once that's installed, we're in good shape there. The next thing we need to do is assemble our curl. So we need the bucket name and the identifier. So I'm going to go to here. And I'm just going to open up our code deploy app here, make a new file, just so I have a bit of a scratch pad to work with, because I need to grab the region. So we are in this one here, the bucket name. So we need this. And then we need US East 1. And then we need to copy the link. Where'd the link go? I'm whizzing all over the place. I don't know where I am. Okay, here we are. And so we're going to copy this and put that in as the bucket name, and then copy this and put that in as the region identifier. And so we'll need to make a curl command, and then I think we can go like this. And we probably want to put it in our home EC2 user. Install is probably a good place for it. I never can remember which way the arrow goes, but we'll try it this way. And if it's not, we'll flip that arrow to the left. But it seems like this should go into that. We'll go back to Sessions Manager here. I'm just going to hit enter. I don't know if we switched to sudo when we went into here. It's a good question. Sudo su-ec2 user. Okay, do we have Ruby? Oh yeah, we do. Great. And so I'll just paste that in there again. Oh, whoops. We don't need the wget in there. That was an accident. We'll do ls-la. There is our install file, and so we can proceed to do the rest here. So we'll chmod that file, make it executable. And then we will then go ahead and install that. That shouldn't take too long. And let's just confirm that it is running. That is great. And just one more thing, we're just going to remove that install file. So now that we have our code deploy agent, we should be able to deploy. I also think there was one other minor mistake. If we go into, we'll just remove this file, we don't need it. If we go into here, I was thinking I need the absolute path here. I don't. So just remove that out of your restart app. And we'll go back to code deploy. And we'll go back a step here. Oh, we'll have to rebundle our update.sh because that has changed. So just go here and delete this file here. And we have that zip there still. So if you don't have it, just hit up until you get it. And then we will just copy that back there. It should replace that there. There we go. And we'll make our way back to code deploy. And I'm pretty sure we can just do a retry. I don't think it caches the zip. So let's just hit retry. Because it should pull it every time, right? And maybe we'll have better luck this time. And this should be really fast because in-place deploys are super, super fast. Oh, look at that. Look how fast that was. Look how fast that was. That was so impressive. Okay, so let's go check out that instance. We can probably go to the deployment group here. Click into that deploy. And now we have the instance ID, so we'll click on that. We will get our public IP address here. And there you go. So that is in-place code deploy. Blue-green deployments are a lot more involved, and I don't think it's worth our time because I feel that it would take like an additional 30-40 minutes just to do a blue-green deployment. But blue-green deployment, what it does, I can just pull up maybe the deployment group here, so we can just talk about it for a second. But the deployment group, when you have in place in blue-green, blue-green relies on an EC2 auto-scaling group. So for that to work, there's this manually provision. I've never used that. But with the EC2 auto-scaling group, the idea is that we would have to put our instance in an auto-scaling group, and then it would use that. So then when a blue-green occurred, it would copy that auto-scaling group. It would launch a new EC2 instance, and then it would apply the versions of that. That's why we baked the AMI, because I thought that we would have to spin up another instance. But, you know, I don't think we need to do that. That's more like the SysOps Associate or the DevOps Pro, and we're doing the Developer Associate here. But you know what we could do as an additional layer is set up code pipeline so that we can automatically deploy every time there is a push to code commit. So I think that's what we'll do next. And that will, I guess, be our code pipeline follow along, but we will just attach it onto this. Okay, so let's set up a code pipeline. And we are going to definitely need a code commit repository. And that's why we set one up earlier in this code deploy follow along. So what I want you to do is make your way back to Cloud9. And we're just going to close a couple of these things here. We got a lot of stuff going on here. And remember, we have this Git directory. So just make sure you're in it. So just make sure you're in that, my code app, whatever you called it. And we need to commit some files. We definitely do not want this revision file in here, the zip. So we're going to go ahead and delete that out. App spec, index, restart. Yep, this is all good. So we're going to go git add all. And I'm actually going to change this to version 3. And we'll say git commit -m version 3. And then we will do a git push. Don't worry about these errors here. These aren't important. I got to type git push right for it to, there's no command called git push, but we have to successfully push here. We will go back up to code commit. We'll just make sure that our changes are there. And we'll go into my code app. And there are our files. So let's make our way over to code pipeline. So we'll go to code pipeline. And this shouldn't be too hard. This should be pretty darn easy. So we'll go create a pipeline, my code pipeline. We'll let it create a new service role. That sounds great to me. I didn't know you could change the artifact location. I would just set the default one. We'll go next. We'll choose code commit. And then we will choose our repo here. We will choose the master branch. And we'll let Amazon CloudWatch monitor that. That seems a good idea to me. We are not going to have a build stage. We'll skip that. There's nothing for us to build. So, but you have to either have a build or deploy. It will not let you build a pipeline without one or the other. We're going to use code deploy here. We're going to choose our application. We'll choose our deployment group. We'll go to next. And we will create a pipeline. All right, so it already started trying to deploy and it's already failed. If we go check the message here, we got an error message saying the action failed because the encryption key used by AWS code commit is unavailable. Make sure the encryption key is available and try again. So that tells me that it's probably a policy issue. So maybe when we set up our code pipeline, we created a policy with it. I bet it did. So let's look for that IAM policy wherever it is. Not sure how we would locate it. It definitely made one. So what we'll do is we'll just go over to IAM and just take a guess. So we'll go over here. And we'll just go to roles, I suppose, and we'll just type in code pipeline. Yep, and that's the pipeline I just made. Just double checking here. Code pipeline, service role, my code pipeline. So I think what we'll do is we'll just add KMS. KMS, key. It was key management. Will this do it? List, read, write. Let's give it a go. Usually you shouldn't be that liberal with your KMS access here, but if that fixes our problem here, we're going to be in better shape. So I'm going to say release changes again, and we will release. And we'll see if we have better luck this time around. And there's no refresh button on here. I guess it's just happening in real time here. Oh, look at that. So that's all it took to fix that issue there. And we'll see if this deploy is just successful. And this should be really fast, the deploy section. So we will just wait here patiently. We can click into it as well, see how it's doing. So it's already done. So maybe that was a bit misleading there. Yep, it's already done. And so let's go check out that EC2 instance. So we'll go into code deploy here. We will check in, we'll click into that deployment group. We'll go to the last deploy. We'll go down to here. It would be easy if we just kept that tab open. And then we will go get that IP address, paste it in. Still says version 2. I don't trust it. So I'm just going to open up Firefox and be back here in a second, because sometimes Chrome caches. Actually, we can just go here to inspect, and we'll go to performance network. Make sure cache is disabled. Refresh. So it says version 2. Okay. All right, well, let me just investigate. I'll be back here in a moment. All right, so what I did was I downloaded this file, I opened it up, and I wanted to see if it said version 3 in it, and it didn't. It said version 2. So I guess the code it bundled was the old version. That is a little bit confusing to me, but instead of thinking about it too hard, let's just trigger a new deploy to our pipeline and see if that just resolves itself. So I'm going to go to our code pipeline here. We'll click into this, and I'm just going to trigger it by pushing new code here. So let's make it version 4 this time, even though we never saw version 3. And what we'll do here is we'll do git add all. Another thing is that it's copying those files into that revision directory. I don't know if it deletes the old files for the revisions. So that's something I might want to consider. When we're talking about the appspec YAML file, we use this script to, like, they go here, but I would assume that it would always replace them. But it doesn't matter because the zip contained version 2. So what we'll do is we're just going to go ahead and commit our changes here, git status. So do git add period, git commit -m version 4. We'll do a git push. Not push. Push is not a command. We'll go back to the top here, and we'll see if this is triggered. So this should be triggering. There we go. So it's in progress. So now we just have to wait and see what happens. And while this is going, let's go check out code commit, and let's just make sure that we have the latest version in there. I'm very certain that we do. But, you know, sometimes things just don't go the way you want them to go. If you go into here, this says version 4, right? Okay, so that succeeded, and we will not have to wait very long here for the deploy. Deploys are super, super fast. We can even click into this. It's probably already done. Yep, it's already done. Go back here, refresh. Version 4. So I don't know why that was an issue. That was the initial commit, so that's why I didn't trust it too much, and I just figured we'd do another deploy. Yeah, there you go. So that's all you had to do to set up code pipeline. So yeah, we didn't show the code build step, but you know, it's not that big of a deal. But anyway, there you go. All right, so we probably should do a bit of cleanup here. So what we'll do is we'll go to code pipeline, which should be on the left-hand side here. We'll make our way over to the pipelines here, and we will delete this pipeline. Delete. Great. And the next thing we'll do is go to code deploy, and we'll go to applications, and we'll delete that application wherever we can. View details, delete application, delete. And then we will go to code commit. So I don't need a bunch of repos I'm never going to use. So let's go ahead and delete this one. Delete. And then we'll go to EC2. And we will terminate that instance. Code deploy. Terminate. Yes. And we also made an AMI, so might as well get rid of that. We're not using it for anything. Deregister. So what do they call it? Yeah, we will deregister this image. Don't know why they just don't call it delete. And that's all our cleanup. So yeah, we're all done here. Okay, so we're on to the code deploy cheat sheet, and this is a fully managed deploy pipeline to deploy to staging and production environments. We can deploy to EC2, on-prem, Lambda, or ECS. We can perform in-place or blue-green deployments. Let's talk about those two right now. So for in-place, instances are briefly taken offline, updates are applied to existing servers, and they're brought back into service. For blue-green, it replaces the instances with new instances, swapping the environments. And now talking about the code deploy core components, we have the application. That encompasses all other components, which will follow this one immediately. and we have a unique ID of the application being deployed. Deployment groups is a set of EC2 instances or Lambda functions where the new revision is to be deployed to. Then you have deployments. This is the process and components used to apply a new application revision. We have deployment configuration, a set of deployment rules used during deployment with success failure conditions included. We have our AppSpec YAML file, which is super important to know, contains the deployment actions that the code deploy should execute during the deployment. Then you have revisions. This is everything required to deploy a new version. So that's your AppSpec file, application files, config files, and executables. Now talking more in detail about the AppSpec YAML, this describes the deploy instructions and must be part of the deploy artifact. And the last thing I want to tell you is you need to install the code deploy agent on EC2 instances so it can communicate with code deploy. And you need to create the code deploy service role and add it to your EC2 instances so they have permissions to communicate to code deploy. And so code deploy has permissions to replicate servers or ASGs. Those last two maybe might not show up on the exam, but will save you so much time of debugging. And you can even see in the follow along, I had trouble there. So I always forget those, but they're extremely important. So there you go. That's code deploy. Hey, this is Andrew Brown from Exam Pro, and we are looking at Code Pipeline, which is a fully managed CI/CD pipeline to set up automatic deployments. All right, so let's look at the anatomy of a code pipeline. So here I have a technical architecture that has all the components, and starting at the top, we're going to look at the pipeline itself, and this is what encompasses all the components. Then you have stage. And so we have multiple stages and they represent a step in the pipeline. The most common setup would be source, build, and deploy. When you first set up Code Pipeline, they force you to set up these 3 stages. But after that, you can set up as many stages as you like. So there's a lot of creativity here. You don't have to be limited to those 3. Then you have action groups, which group together several actions. And then you have actions, and this does something. It can pull code or build and run tests, deploy code to production, invoke a Lambda, invoke CloudFormation templates, a lot of things you can do there. Then you have artifacts, and artifacts are just zips that contain files that were outputted by an action, and they're generally stored in S3. So an artifact can be passed to future actions, and they can be referenced anywhere in the future stage. So something that was outputted in the build could be accessed in the deploy. It doesn't have to go from step to step. But some actions require an input from an artifact or maybe a source, and generally they have an optional output for an artifact. So you don't have to output one, but you definitely can. And the last thing are stage transitions, and this is what links the stages of a pipeline to the next one. So those are all our components, so let's move forward. So in Code Pipeline, actions is where all the magic happens. And so there's a lot of possible actions for you to take, and actions are not restricted to specific stages. So if you want to have a deploy action in your build stage, you can definitely do so. Pipelines are only limited by your creativity, and you can create custom actions if you need functionality beyond this list. And so let's get into the available actions to us. So we have source. So this is where we're pulling code from some repository. We have code commit, ECR, S3. They now have support for Bitbucket, which is long overdue, and GitHub. Then you have your test actions. The most common ones you're going to be using are code build and Jenkins. But you can see we have a bunch of other ones there, and these are for building and generally for building code and then running test suites and getting test coverage. Then you have your deploy actions, the most popular being CloudFormation and Code Deploy, and then we have a bunch of other ones there like Elastic Beanstalk, Alexa Skill Kit, and to Amazon S3. And then our last code pipeline action here is to invoke a Lambda, very underappreciated, very useful action in the code pipeline process. And there's a bit of overlap here because in step functions, you can chain a lot of Lambdas together, or even a Lambda, you can have a source destination chain them. But, you have to think about the context of what code pipeline is. And so if it's for CI/CD, it makes sense to use Lambdas there. So yeah, that's all the actions. So here I have an example of a code pipeline, and this is an early version of the Exam Pro pipeline to deploy the application. It's very simple. There's only two stages here. We have a source and deploy. You don't necessarily have to have a build step. And so we have this source stage, which has an action where it's using the source action as GitHub. So when a pull request is merged into master on GitHub, what it's going to do is trigger the source action to pull the latest code. And once it pulls that code, that source action is going to output an artifact containing the latest code. And then a stage transition is going to occur. And then code deploy is going to take that source output, so the output artifact from the first step, and use it to create a new auto-scaling group, and then update the EC2 servers with that artifact. And then it's going to then run a script that's going to shut down and restart those servers. And then when health checks paths with the new auto-scaling group, it's going to shift over the traffic and delete the old auto-scaling group. So there you go. That's a very simple example of one. So I just want to show you some use cases for code pipeline. So some variation in terms of how the pipelines can vary. So let's look at them, starting with traditional monolithic application. So this would be if you're deploying a Ruby on Rails app or a Django or a Laravel application. So you normally have a source, build, and deploy stage. You'd have your source could be like GitHub. That would output a source artifact. Then you'd go to your code build step. And in this step, you are building to test the code to make sure everything is working as expected. And that build artifact is going to output the results saying, yes, all the tests pass, test coverage is good. And then it's going to proceed to deploy, and then it's going to do a deploy. So that's the traditional architecture. Then moving on to, let's say you're hosting a marketing website on static S3, you could build a code pipeline for that. So your source could be Bitbucket. Bitbucket's going to output that source artifact. That's going to go into code build, and then code build is going to use whatever tool you're using. So if you're using something like Gatsby to build using the Jamstack to build, and you have to generate out those static pages, you could use code build for that, and then output the static pages into a build artifact, pass it to a Lambda, and that Lambda is going to then upload it to the correct S3 bucket, and then invalidate the cache on CloudFront. And so that is that pipeline. Then our last one here is a serverless function. So you could use code commit. That would output a source artifact, which would then go to CloudFormation. CloudFormation is very common for deploying serverless applications, and it would probably be using SAM, the serverless application model for that. But yeah, those are three pipelines. And we are at the end of the code pipeline section, so on to the code pipeline cheat sheet. So the code pipeline is a fully managed CI/CD pipeline to set up automatic deployments. And looking at the anatomy of a code deploy, obviously we have the pipeline, and this encompasses all the components which we're going to look at right now. So we have stage, and this is a step in the pipeline. So the stages here would be source, build, and deploy. Then you have action groups, and this groups several actions together. I don't really understand this myself. It will not show up on the exam, but it is a component of code deploy. Then you have actions. So this is when code pipeline does something. It could do a deploy, it could build, it could invoke. So here it could invoke a Lambda. It could run a CloudFormation template. There's a lot of things here, but the details for that is not important for the exam. Then you have artifacts. So it's a zipped stored in S3 containing outputted files from an action to pass along to another stage of the pipeline. And you also have stage transition. This links to the next pipeline stage. And so we'll just look at some use cases here for code pipeline. I think we have three. So automatically deploy a traditional application. So that could be like Ruby on Rails, Django, Laravel. Automatically deploy serverless applications. So that would be using Lambdas, step functions. And the last here would be automatically deploy statically generated websites. So that would be Jamstack, Gatsby, and stuff like that. So if you generally know what code pipeline is, you'll be good for the exam. Hey, this is Andrew Brown from Exam Pro, and we are looking at CodeStar, which helps you quickly develop, build, and deploy applications on AWS. So let's get to it. All right, so looking at CodeStar here, it is a wizard for getting common application projects set up. You get a deployment pipeline, access management, and a project dashboard to monitor infrastructure. I would say one of the biggest values here is that you get that deployment pipeline. So it would be setting up code pipeline for you, which can be very difficult for a lot of people to figure out how to get that set up for you. And you can get started with a lot of different kinds of projects. So for example, you can get started with Elastic Beanstalk with Ruby on Rails. You can get started with a serverless project. You can get started with an Alexa project. And you can get started with something like Python or Django, but that's with EC2 instances with a load balancer. So it does really abstract away a lot of the infrastructure you would have to implement. And then you do get this nice dashboard that you can work with. So let's look further. So just looking at that process here, how you'd create a project. First, you'd select a template. So here I got Ruby on Rails on an EC2 instance. And then the next thing you're going to do is choose whether you want this to be in CodeCommit or GitHub. And it's creating a new repo for you. So you name the repo whatever you want. It's going to put all the code in there for you. It's going to basically clone whatever they have over there. And then the next thing is you're going to choose to configure this pipeline. So there it's using code pipeline. You can see that we have all those steps in there. And you'll work your way through that until you get to a project dashboard. Hey, this is Andrew Brown from Exam Pro, and we are looking at Relational Database Service, RDS, which is a managed relational database service and supports multiple SQL engines, easy to scale, backup, and secure. So jumping into RDS. RDS is a relational database service, and it is the AWS solution for relational databases. So there are 6 relational database options currently available on AWS. So we have Amazon Aurora, which we have a whole section dedicated on, MySQL, MariaDB, Postgres, which is what we use at Exam Pro, Oracle, and Microsoft SQL. So let's look at what we can do for encryption. So you can turn on encryption at rest for all RDS engines. I've noticed that you might not be able to turn on encryption for older versions of some engines. So sometimes this option is not available, but generally it always is. And also when you do turn on encryption, it's also going to encrypt as well as your automated backups, your snapshots, and your read replicas related to that database. And encryption is handled by AWS Key Management Service, KMS, because it always is. So you can see it's as simple as turning on encryption, and you can either use the default key or provide another KMS key that you created. So now we're taking a look here at RDS backups, okay? So we have 2 solutions available to us, starting with automated backups. What you're gonna do is you're gonna choose a retention period between 1 and 35 days. Now, generally, most people are going to set this to 7. And if you were to set it to 0, that's actually how you turn it off. So when they say that automated backups are enabled by default, they just mean that they fill it in with like 7 by default for you. And you can just turn that to 0. It's going to store transaction logs throughout the day. All the data is going to be stored inside S3. And there is no additional charge for those backups, okay? You're going to define when you want backups to occur through a backup window. So here you can see UTC 6, and the duration can't be longer than a half an hour. And then storage and I/O may be suspended during backup. So just understand that you might have some issues during that period of time. So you might really want to choose that time carefully. Now, the other way is manual snapshots, and all you have to do is drop down actions and take a snapshot. So it is a manual process. Now, if your primary database or your RDS instance was deleted, you're still going to have the snapshot. So if you do want to restore a previous snapshot, you totally can do that. Okay, they don't go when you delete the RDS instance. So let's learn how to actually restore a backup now. And it's as simple as dropping down actions here and choosing restore to point in time. So when recovering, AWS will take the most recent daily backup and apply transaction log data relevant to that day. This allows point-in-time recovery down to a second inside the retention period. Backup data is never restored over top of an existing instance. What it's going to do is when you restore an automated backup or a manual snapshot, it's going to create a new instance from that for the created restored database, okay? And so when you do make this new restored RDS instance, it's going to have a new DNS endpoint, and you are going to have to do a little bit of manual labor here because you're going to want to delete your old instance and then use this new endpoint for your applications, okay? So So we're going to be looking at multi-AZ deployment, and this ensures your database remains available if another AZ becomes unavailable. So what it's going to do, it's going to make an exact copy of your database in another availability zone, and AWS is automatically going to synchronize those changes from the primary database, the master database, over to the standby database, okay? So the thing about the standby is that it is a slave database. It is not receiving any real-time traffic. It is just there as a backup to take the place of the master database in the case that the AZ goes down. So over here we have automatic failover protection. So if the AZ does go down, then failover will occur. It's going to point, there's like a URL or address that says that points to the database. So it's going to point to the slave, and the slave is going to be promoted to master, and now it is your master database. All right, so that's multi-AZ. So now we're going to take a look at read replicas, and they allow you to run multiple copies of your database. These copies only allow reads, so you can't do writes to them, and it's intended to alleviate the workload of your primary database, also known as your master database, to improve performance, okay? So in order to use read replicas, you must have automatic backups enabled, and in order to create a replica, you're just dropping down actions here and hitting create read replica. It's easy as that, and it uses asynchronous replication between your master and your read replica. So you can have up to 5 replicas of a database. Each read replica will have its own DNS endpoint. You can have multi-AZ replicas, cross-region replicas, and even replicas of replicas. Replicas can be promoted to their own database, but this will break replication, which makes a lot of sense, and no automatic failover. So if the primary copy fails, you must manually update URLs to point at copy. So there you go. So now it's time to compare multi-AZ and read replicas, because it's very important to know the difference between the two. So for replication, multi-AZ has synchronous replication and read replicas have asynchronous replication. For what is actually active on multi-AZ, it's just going to be the primary instance. So the standby, it doesn't do anything. It's just there. If the primary instance becomes unavailable, then it becomes the primary instance. Where read replicas, the primary and all the replicas are being utilized, okay? We're going to have automated backups are taken from the standby. Where read replicas, there are no backups configured by default. Multi-AZ, as the name implies, will span 2 AZs within a single region. Read replicas are within a single AZ, but they can be multi-AZ, cross-AZ, or cross-region, okay? When upgrades are occurring, it's going to happen on the primary database for multi-AZ. When upgrades occur in read replicas, it's going to be independent from the source instance. And then lastly, we have failover. So automatic failover will happen to standby. And so for read replicas, you're not going to have that automatic failover. You're going to have to manually promote one of those replicas to become the standalone database. Hey, it's Andrew Brown from Exam Pro, and we are looking at Amazon RDS. And so we are going to create our own RDS database, as well as an Aurora database, as well as looking how to migrate from RDS to Aurora. And also maybe we'll look at some backup solutions there and some of the other superfluous features that RDS supplies us. If you're wondering, how do you get to the console here? You go to the top here, type RDS, and click that, and you will end up in the same place as I am. So let's get to it and create our first database, okay? And we're going to do that by going on the left-hand side here to Databases and clicking Create Database. So here we are in the RDS creation interface, and the first thing we're presented with is with standard create and easy create. I assume that this would eliminate some options for us. We're going to stick with standard because we want to have full control over what we're doing here. The next thing is to choose your engine, and so we're going to do Aurora later, and we're going to spin up a Postgres database, which is very popular amongst Ruby on Rails developers, which is my primary web framework that I like to use. Then under templates, this is more configuration for you that allows you to get started very easily. So if you leave this to production here, I want to show you the cost because it's laughably really inexpensive. It's $632 because it's doing a bunch of stuff here. It's running more than one AZ. It's using a very large EC2 instance, and it has provisioned IOPS, okay? And so for our use case, I don't think we want to spend $632, but if you were like an enterprise, it makes sense why they would do do that, but if you aren't paying attention, that's very expensive. And there's obviously the free tier, which is what we will want to use here, but we will configure this so that it will end up as free tier here, and we will learn the options as we go through it. So the first thing is we're going to have a database, so we'll just keep our database name as database1. Then we need to set a master password, so we will set it as Postgres, and we'll see if we can get away with that. Obviously, when you make your real password, you'd use a password generator or let it auto-generate one so it's very long in length. But I just want to be able to work with this database very easily for the purpose of this follow along. Okay. Then we have our DB instance size. So for the DB instance size, you can see it's set to standard classes M. I would say the standard class is more like burstable, which are T2s. And so this is what we're used to when we're saving money. So we have the T2 micro. If you are a very small startup, you would probably be starting on T2 micro and do totally fine for you. So we're going to change it to T2 micro. Okay. And the next thing is storage class. So here we can choose provision IOPS. And so we have faster IOPS, right? But we're going to go with general here because we don't need that crazy amount of IOPS there, and that's going to reduce storage. There is this ability to do storage auto scaling. So this is kind of nice where it dynamically will scale your database to your needs. I think I will just leave that on. I don't see why we wouldn't want to keep that on unless there's additional cost, which I don't believe there is. Then there's multi-AZ, and so that would set up another database for us in another availability zone at a standby. I don't think we need that, so we're going to turn that off. But just to show you how easy it is to turn that on. Then we're going to need to choose our VPC. It's very important, whatever web application you are deploying, that your RDS database is in the same VPC, or it's going to be a bit of trouble trying to connect to it. So we'll just leave that in the default there. There's some additional connectivity options here. And so it has a subnet group, so we're going to have it to default. We're going to ask whether we want this to be publicly accessible. Generally, you're not going to want a public IP address, but if we want to interact with this database very easily, I'm going to set it to yes for the sake of this follow along, because it would be nice to put some data into this database, interact with it with Table Plus, and then we'll go ahead and delete it. Okay. Then down below we have a VPC security group. I'm thinking that it will probably create one for us by default, so we'll leave it with the default one, which is totally fine. We can choose our preference for AZ. I don't care. We'll leave it by default. And then we have the port number 5432, which is the standard port number there. You might want to change it just for the sake of security reasons, because if you change the port number, then people have to guess what it is. And there's some additional configurations here. So what we have is the initial database name. If you're not specified when RDS does not create a database. Okay, so we probably want to name our database here. So I'm just going to name it database1 here. You can also authenticate using IMDb authentication. So if that is one way you want to authenticate to your database, that is definitely a really nice way of doing that. So you might want to have that checkboxed on. Then you have backups. Okay, and so backups are enabled automatically, and they're set for 7 days. If you want to turn backups, which I definitely do, I'm going to set it to 0 days. If we had left that on and created our RDS instance, it would take forever to create, because immediately after it starts up, it's going to then create a backup, and that just takes a long time. You can set the backup window here and select when you want to have it run. There is the chance of interruptions during a backup window, so you definitely want to pick this when it's not the most important usage by your users. We can enable performance insights. I'm pretty sure, I thought that was only accessible for certain classes of database. Advanced Database Performance Monitoring. It offers free tier for 7 days of rolling. Okay, sure, we'll turn it on. But at one point, you had to have a higher tier to be able to use this. Then we have the retention period here for performance insights. I guess it's 7 days. We'll leave that there. Appears to be encrypted by default. That seems like a good thing there. There's an account ID. Kindly ignore my account ID for this account, but this is a burner account, so it's not like you're going to be able to do anything with that ID. We have enhanced monitoring. I don't need that, so I'm going to turn that off. That seems kind of expensive. We can export our logs. That is a good thing to have. we can have it so it automatically upgrades minor versions. That is a very good thing to set. You can also set the window for that. We can turn on deletion protection. I'm not going to have that on because I'm going to want to delete this lickety split. And so there we go. And so it says 1544, but I know that this is free tier because it's using the T2 micro. And so we get things. So even though it doesn't say it's free, I definitely know it's free, but this gives you the true cost. So after your free tier would run out, this is what it would cost, about you $15 per month at the lowest tier, the lowest thing you can get on AWS for your RDS instance. Okay, so let's go ahead and create that database. So I failed creating my database because it turns out database is a reserved word for this engine, and that's totally fine. So we're gonna have to scroll up here and change the database name. And so I'm just gonna change it to Babylon 5, and we're gonna go ahead and create that. And this time we're gonna get our database. And so now we're just waiting for our database to be created here. And so we just saw the region AZ pop into existence here, and it is currently being created. You might have to hit refresh here a few times. So we'll just wait a little bit here until this status has changed. So our database is available, and now we can actually try to make a connection to it and maybe put in some SQL and run a query. And so before we can try to even make a connection, we need to edit our security group, okay? Because we are gonna need access via port 5432 to connect to that instance there. So we'll just edit our inbound rules, and we're gonna drop down and look for Postgres in here. So there's 5432, and we're gonna set it to only our IP because we don't wanna make this publicly accessible. And we will hit save, okay? And so now if we wanna make a connection, we should have no trouble here. I'm just going to close that tab, and we're going to have to collect some information. You're going to need to use a tool such as Table Plus. If you are on Mac or Windows, it's free to download and install. If you are on Linux, you could use I think it's called dbeaver. Okay, so that's an open source SQL tool here. And so I'm going to just make a new connection here, and we're just going to choose Postgres. We're going to fill in some information. So I called this Babylon 5. Okay, and that was the name of the database as well, Babylon 5. All right, and the username was Postgres, and the very not secure password is Postgres as well. Again, if you are doing this for production or any case, you should really generate out a very long password there. And then we need the host. So the host is going to be this endpoint here, okay? And the port is 5432 by default, so I don't have to do anything special here. And I'm just going to hit test and see if we connect, okay? And so it went green, so that is great. I'm going to hit save, so I can save myself some trouble here. And I will just double click and make a connection. There is a bit of latency here when you are connecting to RDS and just running things. So if you don't see things immediately, just give it a little bit of time or hit the refresh here. But I already have a SQL script prepared here. I'm just going to show it to you. So this is a script, and what it does, actually it shouldn't have been called the Babylon 5 database because I'm mixing Star Trek with Babylon 5. Ridiculous, right? But this is a bunch of ship classes from Star Trek and a bunch of starships from Star Trek here, and I'm going to run the script to get us some data here. Okay, and so if we do it for Table Plus, we're gonna go import from SQL dump, and I have it on my desktop here called Starfleet Ship Registry. I'm gonna hit open. Okay, I'm gonna hit import. It's going to run that script and import us our data here into Postgres. Now, if you're using a different database type as MySQL or Oracle, I can't guarantee that this will work, but it will definitely work for Postgres because SQL does vary based on engines, okay? And so it says it's successfully done, and it even tells us to do a refresh here. There is a nice refresh button up there that you can click, and we're going to wait for our tables to appear. So there we are. We have our ship classes, and we also have our starships, okay? And I just want to run one query here to make sure queries are working. I'm sure it's going to work. And we're going to go over here, and we're just going to get out, we're going to want to pull all the starships that are of ship class defiant, okay, and we'll just make a new query here and run we'll just say run all, okay, and so there you go. So we're getting data. So that's how you can connect to your RDS database. You just have to open up that port number there. If you were to connect this to your web application, what you'd probably want to do for your security group is to just allow 5432 to the security group of the web application. Okay, so here I gave my access to my IP, right? But you just have whatever your security group is, here. So if you had one for your EC2 instances, your auto-scaling group that holds your EC2 instances, you just put that in there. So now that we have our database running, I figured it'd be cool to go check out Performance Insights, which I'm really excited about because this service used to be only available to a certain expensive tier. So you had to pay, I don't know, it was like a T2 large before you could utilize this. But now it looks like AWS has brought it down all the way to the T2 micro. And it just gives you some rich performance insights into your application here. So here I actually ran that query. It actually shows me kind of the performance over time. So this is really great to see here. I bet if I was to perform another query, it would reappear. So I could probably just run the same one here and we could just change it to a different class. So we're just gonna go here and change it. We'll just pick one at random, like this one here. Okay, and I'll just run that there. And so I ran that query, and I'm not sure how real time this is because I've actually never had a chance to use it until now because I just never wanted to upgrade for that there. So it looks like it does take a little bit of time for those queries to appear, but I did run a query there, so I bet it will come in. It probably is, it says past 5 minutes, so I'm going to assume that it's at a 5 minute interval. So if we waited 5 minutes, I'm sure this query would show up there. But it's just nice to know that you can get these kind of rich analytics here, because normally you'd have to pay for Datadog or some other third-party service, and now it's free with AWS. So I just want to quickly show you that you can reserve instances with RDS, just like EC2. And you can start saving money. So just go to the Reserved Instances tab here and go to Purchase Reserved DB Instances. And we're going to have to wait a little bit of time here for this to load. It's probably because it's getting the most up-to-date information about pricing. And so what we're going to do is just go through this here and just kind of get an idea of the difference in cost. So we're going to drop down and choose Postgres as our database. I always seem I have to select that twice. Okay, but now I have Postgres selected. We are using a T2 micro, okay? We are not doing multi-AZ. One term seems great to me. We will first start with no upfront. We only want one DB instance, and we'll look at what we're getting. So here it's going to tell us what we're going to save. So it's going to say it's at 0.014 cents per hour. So to compare this, I have the pricing up here. So for a T2 micro, it is 0.0018 there, okay? And so that's your savings there. So if you just fiddle with this, you'll see now it's 007, which is considerably cheaper, and you have all up front, and that can't be right. It says 000. Well, I guess that would be the case because you've already paid for it, so there'd be no hourly charge. That makes total sense. But now you have an idea what that cost is for the year. So for $111, your cost is totally covered for you. And so if we wanted to actually calculate the full cost here, we would just go here, and generally the number is between, we will actually grab the full price here to get a comparison. Where is our T2 micro buddy here? Here it is. So I always just do 730 times, because that's generally how many hours there are in a month. 730 by that, so that you have basically a $14 charge. So you say 14 times 12, okay? And so it's $168 for the year. So if you're paying upfront for 1 year, we are saving about $50. If we go in for 3 years, we're saving more money. I'm not going to do the math on that, but you get the idea. So just be aware those options are available to us. At the T2 micro stage, it's not a huge impact, but when you get to these larger instances, you definitely want your savings, okay? So yeah, there you go. So I'm going to show you how to create a snapshot for your database. It's pretty darn straightforward. We're going to go into our database, go to our maintenance and backups. If we had backups, they would be turned on here. And so just to take a snapshot, which is the manual process of backing up, we can name our snapshot whatever we want. So I can just say first snapshot there. Okay, and then we'll just press take snapshot. And it's just going to go from into a creating state, and we're just going to now wait for that snapshot to complete. So our snapshot is now available to us, and so there's a few things we can do with it. This only took about 7 minutes. I didn't wait that long for the snapshot here. But if we go to the top here to actions, there's a few things we can do. We can restore our snapshots. So that's the first thing we're going to look at here. And so you're going to be presented with a bunch of options to pretty much spin up a new RDS instance here. And so the reason why you might want to do this is you have a database and you have outrun or outlived the size that you're currently using. So if you're using that T2 micro, which is super small here, we'll just show T3 micro here as an example, and you wanted to increase to the next size, you would do so. And you could also switch to multi-AZ, change your storage type here, etc. And then you could restore it, which will spin up a new RDS instance, okay? And then you would just kill your old one and move your endpoints over to this one, all right? So that's one thing we can do here with restoring a snapshot. The other is migrating a snapshot, okay? And so we'll look into that next here. So just before we get onto a migrate snapshot, let's take a look at copy and share. So copy allows you to move your snapshot to another region. So if you need to migrate your snapshot somewhere else, this is how you're going to go about doing that. And then you can also enable encryption. So if you don't have encryption enabled, this is a good opportunity for you to encrypt your snapshot. So when you launch your RDS instance, it will be encrypted, okay? Just like an EC2 instance. And so then we have the ability to share. So now let's say you wanted to make this snapshot available to other people via other AWS accounts. Well, you'd add their ID here. And so now they would be able to reference that snapshot ID and utilize it. You could also set it to public so that anyone could access the snapshot. But you know, we're just going to leave that alone just so you are aware of those two options. Now, the one that is of most interest is migrate. And so this is how you're going to create an Aurora database, okay? So you can just directly create an Aurora database, but if you wanted to migrate from your RDS Postgres to Aurora Postgres, this is how you're gonna go about it, okay? So we're just going to choose, obviously, Aurora Postgres because we're dealing with the Postgres database here. Then we have our engine version, okay? So this is an opportunity where we could upgrade our version. We're going to change our instance class. Now, Aurora instances are a lot larger than your normal RDS instances, so we're not gonna have a T2 micro here. You might wanna skip this step because it is kind of expensive and you might forget about it. So you don't want to leave this thing running. So down below, I'm going to just choose T2 medium because that is the least expensive option I have here. And I'm just going to end up deleting this anyway, so it's not a big deal. Then we can choose our VPC. We're going to leave it to the default here. We can make it publicly accessible. I'm going to leave it publicly accessible here because I don't care. Yeah, so there you go. And we'll just scroll down here and we will migrate, okay? And so you might get a complaint here. Sometimes I get that. And so what I normally do is I just go ahead and hit migrate again. Okay. Let me just drop down the version. Maybe it won't let us do it for version 10.6. Okay. And we'll hit migrate once more time. It's funny, as soon as you choose 10.7, you have to re-choose your instance class there. So we'll go back to T3 medium there and now hit migrate. Okay. And so now it's going to go ahead and create that cluster there. So it's going to go ahead and create that cluster. You can see here we had two previous failed attempts there when I hit save there. So those will vanish, but we're just going to wait a while for this to spin up. So our migration has completed, and so our RDS instance is now running on Aurora. So let's just take a quick peek inside of here. It did take a considerable amount of time. I think I was waiting about like 20 minutes for this Aurora instance to get up here. And so right away, you're going to see that we have a cluster, and then we have the writer underneath. We have two endpoints, one for writing and one for reading. And you can obviously create your own custom endpoints here. But we're just going to go back here. And I just want to show you that you can connect to this database. So going back to Table Plus, we're going to create a new connection, and it inherited all the settings from our previous database. So just grabbing the reader endpoint here, I'm just going to paste in the host name. We called the user was Postgres. The password was Postgres. Not a very secure password, by the way. The database is called Babylon 5. Okay, and we'll just say this is our Aurora Babylon 5. Babylon 5. I don't know why I'm having such a hard time spelling that today. Okay. I think I spelt it wrong there. Oh, okay. But anyway, let's just test our connection to see here if it works. Definitely I've spelt something wrong here. Okay. And there we go. So it's the same credentials, right? Just the host has changed, and I can obviously connect to that, and we will see, we'll have read-only access to our data there. So yeah, it's the same process. Yeah, and there you go. So just to peek around here, you can create additional readers. So you have more read replicas. We also have this option for activity stream, which is for auditing all the activity. So this might be for an enterprise requirement there for you, but we're pretty much done with this cluster here. So I'm just going to go to databases here, and I'm just going to terminate it here. And so when we want to terminate that here, we're having to go down here and just delete, and we just type in delete me. Okay, and that's going to take out the whole thing here. Okay, so once this is done here, we'll just have to hit refresh there, and this will take a considerable amount of time. See, it's deleting both. Then this Aurora will be gone here. So yeah, there you are. So we created an RDS Postgres database. We connected to it. We migrated it to Aurora, but I wanted to show you a little bit more with Aurora because I don't feel like we got to look at all the options here, and we're only going to be able to see that by creating a new instance here. So we're going to stick with the standard create there. We're going to have Amazon Aurora. We have the option between MySQL and Postgres. We're going to select Postgres, which is going to have on the version 10.7 there. And what I really want to show you here is this database feature setting. So we had this set here, which had one writer and multiple readers. And so you're continuously paying for Aurora there, and it's very expensive. But we have this option called serverless, and serverless is a very inexpensive option. So let's say we were building a web application and it was in development, so only some few clients were using it, or it was only just being used sporadically throughout the month, not a lot of usage. Then serverless is going to be a very cost-effective option for us to use Aurora, and also a way for us to scale up to using Aurora when we need it full time. Okay, so what I'm going to do is just go and set up a serverless Aurora database here. We're going to have it called database 2. We're going to also call it Postgres, give it that very weak password. And this is the big thing here. So we have this capacity setting. So this is only showing up because we have serverless. I'm pretty sure if we checkbox that off, it doesn't appear. So now we just choose our DB instance size, okay? But we're going to go back up here and go to serverless. And so the idea here is that we are choosing, I believe it's called ACU is the acronym for this capacity unit here, but we're going to choose our minimum and our maximum. So at our minimum, we want to use 2 gigabytes of RAM, and at a maximum, we want that, okay? And we have some scaling options here, which we're going to ignore. We're going to launch this in our default VPC. And then they do have a clear warning here. Once you create your database, you cannot change your VPC selection. But I mean, that's the case with EC2 instances or whatever. You always have to create a new one, right? But I guess some people aren't aware of that. We are going to leave these alone here. There is this option here for Web Service Data API. So this allows you to access and run SQL via an HTTP endpoint. This is extremely convenient way of accessing your database here, and it's only available here because we are using serverless. Okay. And this is the same thing with like the query builder. So if you use the query builder or query editor, which it's called that there, by having this enabled, then we can do both. Okay. And we can have a retention period. I'm going to set it to 1 day. I wish I could set it to 0, but with Aurora, you have to have something set up. You can't have backups turned off. And it's going to have encryption by default. So you can see that it's really making sure that we make all the smart decisions here. And we have deletion protection. I'm going to turn that off because I definitely want to be able to delete this. And we're going to hit create database. Okay, so there you go. We're going to just wait for that to create, and then we're going to just see how we can use it with the query editor here, maybe load it up with some data and etc. Right, okay, hello, let's go. So we created our own RDS Postgres database, which is still running here. In fact, we are done with it, so if you want to go ahead and terminate that, I'm just going to go ahead and I don't want to create a final snapshot. I acknowledge I'm going to delete it, and then I have to type delete me. Oh, they always make our lives very difficult here. Okay. So because as long as that's running, that's costing us money. So I'm just going to refresh that. And so again, we've created our RDS Postgres database, and we learned how to migrate it to Aurora. And so I figured we'll now learn a bit about Aurora Serverless. Okay, so I want you to go create a new database here. And we're going to just leave this to the default here, Amazon Aurora. And we'll just talk about the difference between Aurora and Aurora Serverless here, just so you get an idea of the scope of both of them here. So first, we have the option to choose between MySQL and Postgres. And this time around, we're actually going to make a MySQL database. And this just has to do with the fact that it's going to be easier for us to connect via Cloud9, which already has the MySQL client installed on it, okay? And so you can see here we have the option between going regional and global. The difference between these two is with regional, it's only going to launch Aurora in a single region, whereas global, it's going to go multi-region, all right? And then we have our 4 database options for Aurora. And so one is serverless and the other one is using writers and readers. So I believe when we had migrated our RDS Postgres to be Aurora, I believe it was set to this one here, but we're going to be using serverless here. All right, and then down below, it's going to be the same stuff. So we're going to have our database, our username, and our password. Now I have to come up with a password that is 8 in length. So I'm just going to set password 123, password 123. Of course, that is not a secure password. I don't recommend you using that, but I just need something that's easy to remember for this follow along here. And then down below, we have capacity settings. So if this had been selected to something else, we would just be choosing our EC2 instance size. But since serverless is flexible and on demand based on your capacity that you need, you have this thing called Aurora Capacity Unit, also abbreviated to ACU. And so that's just going to be give us flexibility in terms of our usage, okay? We do have some additional options here for scaling. I'm going to leave those alone. And we can choose our VPC and some additional settings here. I'm going to turn on Data API. So this option is hidden underneath. I believe that's what we need to have selected to use the query editor. And this actually allows us to use an API to actually write queries. So this gives us an endpoint, and we just hit that endpoint with our SQL, and then we can get data back. Very, very convenient. I love that feature there. And then we'll move on to our additional configuration here. Notice that you cannot turn off backups. So if I can't set it to 0 days, Aurora enforces you to have backups. And then you also have to have encryption. And so there's also deletion protection. This might be checked on here, so just check it off there. So we have some very good setting defaults, and we'll go ahead and create our Aurora database there. Okay, and so we'll just wait till that's created, and then we'll come back here and then try to connect to it. So our Aurora Serverless is now available to us, and so let's go actually connect to it and play around with our server. And in order to connect to Aurora Serverless is a little bit different because you have to be within the same VPC. We're not going to be able to use Table Plus. So in order to do or to connect to it, we're going to have to launch an EC2 instance. But to make things really easy, we're going to use Cloud9, okay? Because Cloud9 is an IDE that's backed by an EC2 instance, and it already has the MySQL client installed, so it's going to make it really easy for us. So what I want you to do is go to Services here, type in Cloud9, and we will make our way over to the Cloud9 console here, and we'll create ourselves a new environment. And so I'm just going to call this MySQL Aurora Serverless, okay? Because that's all we're going to use this for, okay? And we're going to hit next step, and we're going to create a new EC2 instance. We're going to leave it at T2 micro, the smallest instance there. We're going to launch it with Amazon Linux. It's going to shut down automatically after 30 minutes, so that's great for us. And we'll go ahead and hit next step, okay? And then we'll create that environment. And now we just have to wait for that IDE to spin up here, okay? So it shouldn't take too long. It just takes a few minutes, all right? So our Cloud9 environment here is ready here, and down below we have our environment, and so I can type MySQL, okay? And you can see that the client is installed, but we didn't actually specify any information, so there's no way it's going to connect to anything here. But let's go ahead and let's go to our RDS, because we need to prepare this so we can actually make a connection here for Cloud9. So let's go into the database here and grab this endpoint here. And I've actually prepped a little file over here with the stuff that we need. So we're going to need to prepare this command. But before we even do this, okay, we are going to need to update our security group, okay, because we're going to need to grant access to the security group of that EC2 or that Cloud9 environment. So also on the right-hand side, or left-hand side, we'll open up security groups again here, and we're going to look for this person's or this Cloud9 environment. So we have one here. It's this one up here. Okay, and so I just need this the actual name, the group ID of the security group, and we'll go back to our serverless security group here, and we're going to edit it here. This looks like it's using the default one, which is kind of a mess. We shouldn't be using this one, but I'm going to go ahead here and just remove those, and we'll drop down and choose MySQL, MySQL Aurora, if I can find it in here. There it is. Okay, and we'll just paste that in there, and so that is going to allow the Cloud9 environment to connect to, or have permission to connect to the Aurora serverless there. So going back to our environment, now we're ready to try out that line. So here is our line here, and so we're just going to copy that whole thing in there and paste it in. Okay, it's going to prompt for password, and we made it password 123. And there we are. So we're connected to our database there. And so if we wanted to create whatever we want, it would just be as we were doing with Postgres there. So there you go. That's how you create a Aurora serverless database, and that's how you would go about connecting to it. So now it's just time to do a bit of cleanup here, so we are not incurring any costs. Now, Aurora serverless doesn't cost any money while it's running, so to the RDS cheat sheet, and this one is a 2-pager. So RDS is a relational database service, and it's AWS's solution for relational databases. RDS instances are managed by AWS, so you cannot SSH into the VM running the database. There are 6 relational database options currently available. So we have Aurora, MySQL, MariaDB, Postgres, Oracle, and Microsoft SQL Server. Multi-AZ is an option you can turn on, which makes an exact copy of your database and another AZ that is only a standby. For multi-AZ, AWS automatically synchronizes changes in the database over to the standby copy. Multi-AZ has automatic failover protection, so if one AZ goes down, failover will occur and the standby slave will be promoted to master. Then we have read replicas. Read replicas allow you to run multiple copies of your database. These copies only allow reads, so no writes, and is intended to alleviate the workload of your primary database to improve performance. Read replicas use asynchronous replication. You must have automatic backups enabled to use read replicas. You can have up to 5 read replicas. You can combine read replicas with multi-AZ. You can have read replicas in another region, so we have cross-region read replicas. Read replicas can be promoted to their own database, but this breaks replication. You can have read replicas of read replicas. RDS has 2 backup solutions. We have automated backups and database snapshots. Should be manual snapshots, but it means the same thing. So automated backups, you choose a retention period between 1 and 35 days. There is no additional cost for backup storage. You define your backup window. Then you have manual snapshots. So you manually create backups. If you delete your primary, the manual snapshots will still exist and they can be restored. When you restore an instance, it will create a new database. You just need to delete your old database and point traffic to the new restored database, and you can turn on encryption at rest for RDS via KMS. So there you go. That's the cheat sheet. Hey, this is Andrew Brown from ExamPro, and we are looking at Simple Storage Service, also known as S3, which is an object-based storage service. It's also serverless storage in the cloud, and the key thing is you don't have to worry about file systems or disk space. So to really understand S3, we need to know what object storage is. And so it is a data storage architecture that manages data as objects as opposed to other storage architectures. Other architectures being file systems, where you manage data as files within a file hierarchy, or you have block storage, which manages data as blocks within sectors and tracks. The huge benefit to object storage is you don't have to think about the underlying infrastructure. It just works. And with S3, you have practically unlimited storage. So you just upload stuff. You don't worry about disk space. S3 does come with a really nice console that provides you that interface to upload and access your data. And the 2 most key components to S3 are S3 objects and S3 buckets. So objects is what contains your data, and they're kind of like files. And an object is composed of a key, a value, a version ID, and metadata. So the key is just the name of the file or the object. The value is actually the data itself made up as a sequence of bytes. The version ID, if you're using versioning, and you have to enable that on S3, then each object you upload would have an ID. And then you have metadata, which is just additional information you want to attach to the object. An S3 object can be 0 bytes in size and 5 terabytes. Please note that I really highlighted 0 bytes because that is a common trick question on the exam, because a lot of people think you can't do 0 bytes, and you definitely can. And then you have buckets, and buckets hold objects. They are kind of like top level folders or directories. Buckets can also have folders, which in turn hold objects. So buckets have a concept called folders, and so you can have those objects directly in that bucket or in those folders. When you name an S3 bucket, it's using a universal namespace. So the bucket names must be unique. It's like having a domain name. So you have to really choose unique names, okay? So the concept behind storage classes is that we get to trade retrieval time, accessibility, and durability for cheaper storage. And so when you upload data to S3, by default, it's using standard. And it's really, really fast. It has 99.99% availability. It has 11 nines durability, and it replicates your data across 3 availability zones. And as we go down this list, it's going to get cheaper. We're going to skip over intelligent tiering. We'll come back to that. And we're going to look at standard infrequency access, also known as IA. So it's just as fast as standard. The trade-off here is that it's cheaper if you access files less than once a month. There is an additional retrieval fee when you access that data. But the cost overall is 50% less than standard. So the trade-off here is you're getting reduced availability. Then you have one zone IA, and as the name implies, it only runs your data, or only replicates your data in 1 AZ. So you have reduced durability. So there is a chance that your data could get destroyed. A retrieval fee is applied just like in IA. Your availability is going to drop down to 99.5%, okay? Then you have Glacier, and Glacier is for long-term cold storage. It's for, the trade-off here, though, is that the retrieval is going to take minutes to an hour, but you get extremely, extremely cheap storage. There also is a retrieval fee applied here as well. And Glacier normally is like pitched kind of like its own service, but really it's an S3 service. Then you have Glacier Deep Archive, and this is just like Glacier, except now it's going to take 12 hours before you can access your data. Again, it's very, 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 very cheap at this level. It's the cheapest tier here. And so this is really suited for long archival data. Now, we glossed over intelligent tiering, but let's talk about it. So what it does is it uses machine learning to analyze your object usage and determine the appropriate storage class. So it's going to decide for you what storage class you should use so that you save money, okay? And so that is all of the classes, and we're going to compare them in a big chart in the next slide here. Have here up the comparison of storage classes just to make it a bit easier for you to see what's going on here. So you can see across the board we have durability at the 11 nines across all services. There is reduced durability in one zone IA, but I guess it's trying to say that maybe it has 11 nines in that one zone. I'm not sure. So that one confuses me a bit. But you have to think that if you're only running in one zone, there has to be reduced durability. For availability, it's 99.9% until we hit one zone IA. For Glacier and Glacier Deep Archive, it's not applicable because it's just going to take a really long time to access those files. So availability is like indefinitely slow. We're not going to put a percentage on that. For AZs, it's going to run in 3 or more AZs from standard to standard IA. Actually, across the board, the only one that is reduced is for one zone IA. I always wonder, you know, if you're running in Canada Central, if it would only use the 2 because there's only 2 availability zones there. So it's always a question I have on the top of my head. But anyway, it's always 3 or more AZs. You can see that there is a capacity charge for standard IA and above. There is a storage duration charge for all the tiers with the exception of standard. And then you have your retrieval fees, which are only going to come in your IAs and your Glacier, okay? And then you have the latency, that's how fast you can access files. And you can see MS means milliseconds, so for all these tiers, it's super, super fast. And, you know, it's good to just repeat, but, you know, AWS does give a guarantee of 99.99% availability. It has a guarantee of 11.9's durability. All right, so there you go. That is the big comparison. So now we're taking a look at S3 security. So when you create a bucket, they're all private by default. And AWS really obsesses over not exposing public buckets. They've changed the interface like 3 or 4 times, and they now send you email reminders telling you what buckets are exposed because it's a serious vulnerability for AWS, and people just seem to keep on leaving these buckets open. So when you create a new bucket, you have all public access denied. And if you want to have public access, you have to go check off this for either for your ACLs or your bucket policies, okay? Now in S3, you can turn on logging per request. So you get all the detailed information of what objects were accessed or uploaded, deleted in granular detail. Log files are generated, but they're not put in the same bucket. They're put in a different bucket, okay? Now, to control access to your objects and your buckets, you have 2 options. We have bucket policies and access control lists. So access control lists came first before bucket policies. They are a legacy feature, but they're not depreciated. So it's not faux pas to use them, but they're just simpler in action. And sometimes there are use cases where you might want to use them over bucket policies. And so it's just a very simple way of granting access. You right-click a bucket or an object, and you could choose who. So like there's an option to grant all public access. You could say list the objects, write the objects, or just read and write permissions. And it's as simple as that. Now bucket policies, they're a bit more complicated because you have to write a JSON document policy, but you get a lot more rich, complex rules. If you're ever setting up static S3 hosting, you definitely have to use a bucket policy. And that's what we're looking at here. This is actually the Exampro website where we're saying allow read-only access for get objects to this bucket. And so this is used in a more complicated setup, but that is the difference. So bucket policies are generally used more. They're more complex, and ACLs are just simple, and there's no faux pas from silly. So we talked about security, and a very big feature about that is encryption. And so when you are uploading files to S3, it by default uses SSL or TLS. So that means we're going to have encryption in transit. When it comes to server-side encryption, actually what is sitting on the actual data at rest, we have a few options here. So we have SSE AES, we have SSE KMS, and SSE-C. If you're wondering what SSE stands for, it's server-side encryption. And so for the first option, this is just an algorithm for encryption. So that means that it's going to be 256 bytes in length or characters in length when it uses encryption, which is very long. And S3 is doing all the work here. So it's handling all the encryption for you. Then you have KMS, which is Key Management Service, and it uses envelope encryption. So the key is then encrypted with another key. And with KMS, it's either managed by AWS or managed by you, the keys itself, okay? Then you have customer provided keys. This is where you provide the key yourself. There's not an interface for it here. It's a bit more complicated, but you know, all you need to know is that the C stands for customer provided. Then you have client-side encryption. There's no interface or anything for that. It's just you encrypting the files locally and then uploading them to S3, okay? We're looking at S3 data consistency. Sorry, I don't have any cool graphics for here because it's not a very exciting topic, but we definitely need to know what it is. So when you put data or you write data to S3, which is when you're writing new objects, the consistency is going to be different when you are overwriting files or deleting objects, okay? So when you send new data to S3, as a new object, it's going to be read after write consistency. What that means is as soon as you upload it, you can immediately read the data and it's going to be consistent. Now, when it comes to overwriting and deleting objects, when you overwrite or delete, it's going to take time for S3 to replicate it to all those other AZs. And so if you were to immediately read the data, S3 may return to you an old copy. Now, it only takes like a second or two for it to update, so it might be unlikely in your use case, but you just have to consider that that is a possibility, okay? So we're taking a look at cross-region replication, which provides higher durability in the case of a disaster, okay? And so what we do is we turn it on, and we're going to specify a destination bucket in another region, and it's going to automatically replicate those objects from the source region to that destination region. Now, you can also have it replicate to a bucket in another AWS account. In order to use this feature, you do have to have versioning turned on in both the source and destination bucket. So there you go. Now in S3, you can set on a bucket versioning, and what versioning does is it allows you to version your objects, all right? And the idea here is to help you prevent data loss and just keeping track of versions. So if you had a file, here I have an image called Tarok Nor, the name is the same thing as a key, right? It's gonna have a version ID, and so here we have one which is 111.111, and when we put a new file, like a new object with the exact same key, it's going to create a new version of it, and it's going to give it a new ID, whatever that ID is, 121212. And the idea is now, if you access this object, it's always going to pull the one from the top. And if you were to delete that object, now it's going to access the previous one. So it's a really good way of protecting your data and also if you did need to go get an older version of it, you can actually get any version of the file you want. You just have to specify the version ID. Now, when you do turn on S3 versioning, you cannot disable it after the fact. So you'll see over here, it says enable or suspended. So once it's turned on, you cannot remove versioning from existing files. All you can do is suspend versioning, and you'll have all these base files with one version, all right? So S3 has a feature called Lifecycle Management, and what it does is it automates the process of moving objects to different storage classes or deleting them all together. So down below here, I have a use case. So I have an S3 bucket, and I would create a lifecycle rule here to say after 7 days, I want to move this data to Glacier because I'm unlikely to use that data for the year, but I have to keep it around for compliancy reasons, and I want that cheaper cost. So that's what you do with lifecycle rule. Then you create another lifecycle rule to say after a year, you can go ahead and delete that data. Now, lifecycle management does work with versioning, and it can apply to both current or previous versions. So here you can see you can specify what you're talking about when you're looking at a lifecycle rule. So let's look at transfer acceleration for S3, and what it does is it provides you with fast and secure transfer of files over long distances between your end users and an S3 bucket. So the idea is that you are uploading files and you want to get them to S3 as soon as possible. So what you're going to do is instead of uploading it to S3, you're going to send it to a distinct URL for a edge location nearby. An edge location is just a data center that is as close as you as possible. And once it's uploaded there, it's going to then accelerate the uploading to your S3 bucket using the AWS Backbone Network, which is an optimized network path, all right? And so that's all there is to it. So pre-signed URLs is something you're definitely going to be using in practicality when you're building web applications. So the idea behind it is that you can generate a URL which provides you temporary access to an object to either upload or download object data to that endpoint. So pre-signed URLs are commonly used to provide access to private objects, and you can use the CLI or SDK to generate pre-signed URLs. Actually, that's the only way you can do it. So here using the CLI, you can see I'm specifying the actual object, and I'm saying that it's going to expire after 300, I think that's seconds. And so anyway, the point is that, you know, it's only going to be accessible for that period of time. And what it's going to do is it's going to generate out this very long URL. And you can see it actually has an access access key in here sets the expiry and has the signature, okay? So this is going to authenticate us temporarily to do what we want to do to that object. A very, very common use case is if you have a web application, you need to allow users to download files from a password-protected part of your web app. You'd also expect that those files on S3 would be private. So what you do is you generate out a pre-signed URL, which would expire after something like 5 seconds, enough time for that person to download the file, and that is the concept behind it. So if you're really paranoid about people deleting your objects in S3, what you can do is enable MFA delete. And what that does is it makes you require an MFA code in order to delete said object, all right? Now, in order to enable MFA, you have to jump through a few hoops, and there's some limitations around how you can use it. So what you have to do is you have to make sure versioning is turned on your bucket, or you can't use MFA delete. The other thing is that in order to turn on MFA delete, you have to use the CLI. So here down below, I'm using the CLI, and you can see in the configuration for versioning, I'm setting it to MFA delete enabled. Another caveat is that only the bucket owner logged in as the root user can delete objects from the bucket, all right? So those are your 3 caveats, but this is going to be a really good way to ensure that files do not get deleted by accident. Hey, this is Andrew Brown from Exam Pro, and welcome to the S3 follow along, where we're going to learn how to use S3. So the first thing I want you to notice in the top right corner is that S3 is in a global region. So most services are going to be region specific, and you'd have to switch between them to see the resources of them, but not for S3. You see all your buckets from every single region in one view, which is very convenient. That doesn't mean that buckets don't belong to a region. It's just that the interface here is global, okay? So we're going to go ahead and create our first bucket, and the bucket name has to be unique. So if we choose a name that's already taken by another AWS user, we're not going to be able to name it that. And the name has to be DNS compliant. So it's just like when you register for a domain name, you're not allowed certain characters. So whatever is valid for a domain name or URL is what's going to be valid here. So I'm going to try to name it Exam Pro, and it's going to be in this region here. And we do have all these other options, but honestly, everybody always just goes ahead and creates and configures after the fact. So we're going to hit create. And you're going to notice that it's going to say this bucket name has already been taken. And it definitely has been, because I have it in my other AWS account here. So I'm just going to go ahead and name it something else. I'm going to try 000. Okay. And we're going to hit create. And there we go. So we have our own bucket. All right. Now, if we wanted to go ahead and delete this bucket, I want you to do that right away here. We're going to go ahead and delete this bucket. It's going to pop up here, and it's going to ask us to put in the name of the bucket. So I always just copy it in here like this, and we're going to delete that bucket, okay? So that's how you create a bucket, and that's how you delete a bucket. But we're going to need a bucket to learn about S3, so we're going to have to go ahead and make a new bucket here. So I'm going to put in Exam Pro 000, and we will go ahead and create that. And now we have our bucket. So great. We'll go click into this bucket, and there we go. So let's start actually uploading our first file. So I prepared some files here for upload. And just before I upload them, I'm just going to go create a new folder here in this bucket. Okay. And I have a spelling mistake there. Great. And so I'm going to just go upload these images here. They are from Star Trek The Next Generation. They're the characters in the show. And so all I have to do here is click and drag, and then I can go ahead and hit upload down here. And they're just going to go ahead and upload them. All right. And we'll just give that a little bit of time here, and they are all in. Great. So now that I have all my images here in my bucket, I can click into an individual one here, and you can see who the owner is, when it was uploaded, the storage class, the size of it, and it also has an object URL, which we're going to get to in a moment here. All right. But if we want to actually just view it in the console here, we can click open and we can view it, or we can hit download. All right, and so that's going to download that file there. But then we have this object URL, and this was why we were saying that you have to have unique bucket names, because they literally are used as URLs, okay? So if I were actually to take this URL and try to access it, and I actually just had it open here a second ago, you can see that we're getting an access denied, because by default, S3 buckets are private, okay? So if we wanted to make this public so anyone could access this URL, we want to hit the make public button. But you're going to see that it's disabled. So if we want to be able to make things public, we're going to have to go to our bucket up here at the top here, go to the properties, or sorry, I should say permissions. And we're going to have to allow public access, okay? So this is just an additional security feature that AWS has implemented because people have a really hard time about making things public on their bucket and getting a lot of bad stuff exposed. So we're going to go over here and hit edit, and we have a bunch of options, but we're first going to untick block all public access, and this is going to allow us to now make things public. So I hit save, okay, and then I got to type in confirm, okay. And so now if I go back to our bucket here into the enterprise D and data, I now have the ability to make this public. So I'm going to click make public. And so now this file is public. And if I were to go back here and refresh, okay, so there you go. So now I could take this link and share it with you or anybody, and anyone in the world can now view that file, okay? Great. So now that we learned how to upload a file or files and how to make a file public, let's learn about versioning. So we uploaded all these different files here, but let's say we had a newer version of those files and we wanted to keep track of that. And that's where versioning is going to help us in S3. So, you know, we saw that I uploaded these characters from Star Trek The Next Generation, and there we actually have newer images here of the characters, not all of them, but some of them. And so when I upload them, I don't want the old ones to vanish. I want it to keep track of them, and that's where versioning is going to come into play. So to turn on versioning, we're going to go to Exam Pro 000, and we are going to go to Properties here, and we have a box here to turn on versioning. And I just want you to notice that when you turn on versioning, you cannot turn it off. You can only suspend it, okay? So what that means is that objects are still going to have version history. It's just that you're not going to be able to add additional versions if you turn it off. But we'll go ahead and we're going to enable versioning here. And versioning is now turned on. And you're going to notice now that we have this versions tab here where we go hide and show, and it gives us additional information here for the version ID, okay? So I'm going to go into the Enterprise D, and I'm going to hit show here so I can see the versions, and now you're going to see we got a big mess here. Maybe we'll turn that off here for a second, and we're going to go ahead and upload our new files here, which have the exact same name, okay? So I'm going to click and drag, and we're going to hit upload, and there they go, okay? So we're going to upload those files there. And now let's hit show, and we can see that some of our files where we've done some uploading there have additional versions. So you're going to notice that the first file here actually has no version ID. It's just null, okay? But the latest version does. It's just because these were the initial files. And so the initial files are going to have null there. But you know, from then on, you're going to have these new version IDs, okay? So let's just see if we can see the new version. So we're looking at data before, and what we want to see here is what he looks like now. So I click open, and it's showing us the latest version of data, all right? Now, if we wanted to see the previous version, I think if we drop down here, see where it says latest and prior, so we have some dates there. We click here, we hit open, and now we can see the previous version of data, okay? Now, one other thing I want to check here is if we go up to this file here, and we were to click this link, is this going to be accessible? No, it's not, okay? Now, let's go look at the previous example. Now, we had set this to be public. Is this one still public? It is, okay, great. So what you're seeing here is that when you do upload new files, that you're not going to inherit the original properties like for the public access. So if we want data to be public, we're going to have to set the new one to be public. So we're going to drop down the version here and hit make public. And now if we go open this file here, he should be public. So there you go. That is versioning. Now, if we were to delete this file out of here, let's go ahead and delete data out of here. Okay, so I'm going to hit actions, and I'm going to delete data. So I'm going to hit delete. Notice it says the version ID here. Okay, so I hit delete, and data is still here. So if we go into data and we hit open, okay, now we get the old data, right? So we don't have the previous versions. I'm pretty sure we don't. So we just hit open here, open. Great. And if I go here and go to this one, open. Okay, so this specified version does not exist. So it still shows up in the console, but the file is no longer there, okay? Now, let's say we wanted to delete this original data file, right? Can we do that? Let's go find out. Delete, and we're gonna hit delete. Okay, and it still shows that data's there. We're gonna hit the refresh. We're gonna go in there, and we're going to look at this version and open it. Okay, and so you can still see it's there. So the thing about versioning is that it's a great way to help you protect from the deletion of files. It also allows you to, keep versions of stuff, and those properties, again, does not carry over to the next one. So now that we've learned about versioning, I think it'd be a bit of fun to learn about encryption, okay? Actually, just before we move on to encryption, I just want to double check something here. So if we were to go to versions here, and I was saying like the initial version here is null, but what would happen if we uploaded a file for the first time because remember, these were uploaded before we turned on versioning, right? And so they were set to null. But what happens when we upload a new file with versioning turned on? Is it going to be null, or is it going to have its own version ID, okay? So that's a kind of a burning question I have in the back of my mind. And so I added another image here. We now have Keiko. And so we're going to upload Keiko, and we're going to see, is it going to be null, or is it going to have an ID? And so look, it actually has a version ID. So the only reason these are null is because they existed prior to versioning, okay? So if you see null, that's the reason why. But if you have versioning turned on, and then from then on, it's always going to have a version ID. Actually, just before we move on to encryption, I just want to double check something here. So if we were to go to versions here, and I was saying like the initial version here is null, but what would happen if we uploaded a file for the first time because remember, these were uploaded before we turned on versioning, right? And so they were set to null. But what happens when we upload a new file with versioning turned on? Is it going to be null, or is it going to have its own version ID, okay? So that's a kind of a burning question I have in the back of my mind. And so I added another image here. We now have Keiko. And so we're going to upload Keiko, and we're going to see, is it going to be null, or is it going to have an ID? And so look, it actually has a version ID. So the only reason these are null is because they existed prior to versioning, okay? So if you see null, that's the reason why. But if you have versioning turned on, and then from then on, it's always going to have a version ID. All right, so let's explore how to turn on server-side encryption, which is very easy on S3. So we're going to go back to our bucket, go to our properties, and then click on default encryption. And by default, you're going to see we don't have any encryption turned on, but we can turn on server-side encryption using AES 256, which uses a 256 algorithm in length, or key in length. I'm always bad on that description there, but the point is it's 256 something in length for encryption. And then we have AWS KMS, but we're going to turn on AES 256 because that's the easiest way to get started here. But look at the warning up here. It says the property, this property does not affect existing objects in your bucket, okay? And so we're going to turn on our encryption. So we got our nice purple check mark, and we're going to go back to our bucket to see if any of our files are encrypted, which I don't think they're going to be based on that message there. So we're going to go and check out data, and we can see that there is no server-side encryption, okay? So in order to turn it on for existing files, I would imagine it's going to be the same process here. We'll go to properties, we're going to have encryption here, and we're going to turn on AES 256. So you can see that you can set individual encryption per files, and you can also do it per bucket. And so we're going to go ahead there and encrypt data there. All right. So now if we were to go access this URL, do we have permissions, even though it is set to public? So remember, data is public, right? But can we see it when encryption is turned on? And apparently we totally can. So encryption doesn't necessarily mean that the files aren't accessible, right? It just, because we have made this file public, it just means that when they're at rest on the servers on AWS, they are going to be encrypted, okay? So, that is how easy it is to turn on encryption. Now, when it comes to accessing files via the CLI and KMS, there is a little bit more work involved there. So, for that, it's going to be a bit more of a story there. But, if we do go to the CLI, we'll talk about it then, okay? want to show you how to access private files using pre-signed URL. But just before we get to that, I figured this is a good opportunity to learn how to use the CLI for S3. We'll work our way to a pre-signed URL. So here I have my terminal open, and I already have the AWS CLI installed on my computer here. So what we're going to do first is just list all the buckets within our AWS account. So we can do AWS S3 LS. LS stands for list. And then what it's going to do is we're going to see that single bucket that we do actually have here. And if we wanted to see the contents of it, we could just type AWS S3 LS and then provide the bucket name. And then it's going to show its content, which is a single folder. And then if we wanted to see within that folder, you kind of get where we're going here. We can put that on the end there and hit enter, okay? And then we're going to see all our files. So that's how easy it is to use LS. You're going to notice over here, I do have a slightly different syntax here, which is the using the S3 protocol here in the front. This is sometimes is needed for certain commands, which we're going to find out here with CP in a moment, but not all commands require it, okay? Like, so for instance, in LS, we have omitted that protocol there. But yeah, moving on to copying files, which CP stands for, we can download objects to and from our desktop here. So let's go ahead and actually go download Barkley from our bucket here. So I'm just going to clear this here and type AWS S3 CP, and we're going to use that protocol. We definitely have to use it for CP or we'll error out, and we'll do exam pro 000 enterprise D here. And then it's going to be Barkley, okay? And we're just going to want to download that fellow there to our desktop. Okay, and then we're just going to hit enter there. And it's just complaining because I typed it in manually and I have a spelling mistake. We need an R there, and it should just download that file. Great, so if we go check our desktop, there we go. We've downloaded a file from our S3 bucket. Now, if we want to upload a file, so down in here, I have an additional file here called Q, and I want to get that into my bucket via the CLI. It's going to be the same command. We're just going to do it in the reverse order here. So we're going to do AWS S3 CP, and we're first going to provide the file locally we want to upload here, and that's going to be enterprise D q.jpg. And we're going to want to send that to S3, so we have to specify the protocol, the bucket name, the folder here that it's going to be in, enterprise D, make sure I don't have any spelling mistakes this time, and we're just going to put q.jpg, okay? And we're going to send that there to S3, and you can see it's uploaded. We're going to refresh, and there it's been added to our S3 bucket. Great. So now we know how to list things and upload or download things from S3, and now we can move on to pre-signed URLs. So we saw earlier that with data, we had access to data here because he was public. So if we were to click this fellow here, we can access him, right? But let's say we wanted to access Q that we just uploaded, right? And so by default, they are private. Okay, so if I was to open this, I'm not going to be able to see it. It's access denied, which is good and sane default. But let's say I wanted to give someone temporary access, and this is where pre-signed URLs come. So pre-signed URLs, what it's going to do, it's going to generate a URL with the credentials that we need to be able to temporarily access it, okay? So if I were to copy this AWS S3 pre-signed URL here, well, we'll just type it out because it's not a big deal here. And we're going to try to get access to this Q file here. So we're going to want to do enterprise D, and we're going to say q.jpg, and we're going to put an expires on there. Expires, like by default, I think it's like an hour or something, but we want it to expire after 300 seconds. So people, like these links aren't staying around. They're temporary, right? And I'm just going to hit enter there. And I've made a mistake. I actually forgot to write the word pre-signed in there. Okay. What it's going to do, it's going to spit back a URL. And so if we were to take this URL, right, and then supply it up here, now we actually have access. So that's a way for you to provide temporary access to private files. This is definitely a use case that you'd have if, let's say, you had paid content behind, like in a web application, that you'd have to sign up to gain access. And this is how you give them temporary access to whatever file they wanted. And I just wanted to note, and I think this is the case where if we were to actually open this here, so again, if we have this URL that has the access ID, etc. up there, but if we were to open it up via this tab, I think it does the exact same thing. So it has a security token here. So I guess maybe it's not exactly the same thing, but I was hoping maybe this was actually also using a pre-signed URL here. But anyway, the point is that if you want to access temporary files, you're going to be using pre-signed URLs. So we uploaded all our files here into this bucket, and when we did so, it automatically went to the storage class standard by default. So let's say we wanted to change the storage class for our objects. We're not going to do that at the bucket level. We're going to do it at the object level here. So we're going to go to properties here for Guinan. And all we have to do here is choose the class that we want, so standard IA, and we're going to hit save. And now we can start saving money. So that's all it takes to switch storage classes. But let's say we want to automate that process, because if we were handling a lot of log files, maybe after 30 days, we don't really need them anymore, but we need to hold on to them for the next 7 years. And that's where lifecycle policies are going to come in play. So what we're going to do is we're going to go back to our bucket. We're going to go to management. Here we have lifecycle, and we're going to add a new lifecycle rule. So we'll say, maybe we'll do just for something simple, say, so after 30 days, so 30-day rule. And we could limit the scope of what files we want. So if we wanted to say just enterprise D here, we could do enterprise D, okay? But that's not what I'm going to do. I'm just going to say all files within the actual bucket here, go next. And then we can choose the storage class, so transition. So here we have to decide whether it's the current version or the previous versions, okay? And so I was going to say it's going to be the current version, all right? Always the current version here. We're going to add a transition, and we're going to move anything that's in standard into standard IA, and it's going to be after 30 days. I don't think you can go below that. If I try 7 here, see, so the minimum value here has to be 30. So we're going to have to set it to 30. And I think we saw those minimums in the actual storage class when we were setting them. So if you're wondering what those are, they're probably over there. But we'll just hit next here. And so then after we're saying that it's being transitioned, after 30 days, it's going to move to that. And we can also set an expiration. So we don't necessarily need to set this, but this is if we wanted to actually delete the file. So after current days, we could then say to completely delete the files, which is not what we're going to do. And we're just going to hit next and click that. And now we have a rule that is going to automate the moving of our files from one storage class to another. All right. So there you go. That's lifecycle. So we're going to learn how to set up cross-region replication here. And so this is going to allow us to copy one files from a bucket to another bucket. And this could be in another region and in another AWS account, okay? So there's a few different possibilities here as to why we'd want to do that, but let's just learn how to actually do it. And so we're going to need to create a replication rule, but before we can do that, we're going to need a destination bucket. So we're going to go back here to S3, and we're going to create a new bucket. I'm just going to call it ExamPro BBB. And I'm going to set this to Canada Central, okay? If this name is not available, you're just going to have to come up with your own names here, but just make sure you're setting it to another region for this example here. And so now we have a bucket in the States and in Canada, and we're almost ready to go. We just have to make sure that we have versioning turned on in both buckets, both the source and destination. So we'll go here to our new bucket, turn on versioning, okay? And I already know that we have versioning turned on in our source, but we'll just take a quick look here. So here it is turned on. And so now we are ready to turn on cross-region replication. So we'll go ahead and create our rule in our source bucket. Our source bucket is selected here. Then we'll go next and we will choose our destination bucket. And so now we have a couple options here which can happen during replication. So we can actually change the storage class, which is a good idea if you want to save money. So if the other bucket is just like your backup bucket, and you don't plan to really use those files, you probably would want to change the storage class there to save money. And you can also send this to someone else's bucket in another AWS account. So maybe your use case is this bucket has files and you want to provide it to multiple clients. And so you can use that replication rule to replicate it to their buckets, okay? But this is just going to be our buckets for the time being. And we're going to go ahead here and create a new role. And we'll just call it CCR US to Canada, okay? We'll just create a new rule so we have permissions to go ahead and do that there. And we'll get a nice little summary here and hit save. And we will wait and we will cross our fingers. And it says the replication configuration was not found. So this sometimes happens. It's not a really big deal here. So just go back to replication and it actually did work, I think. So sometimes what happens is the role isn't created in time. So, you know, sometimes it's green and sometimes it's red, but just come back and double check here because it definitely is set. So now we have replication set up. So there you go. So now we're going to learn how to set up bucket policies so we can create custom rules about the type of access we want to allow to our bucket. So in order to do so, we're going to go to our exampro 000 bucket. We're going to go to permissions and we're going to go to bucket policy. Okay. And so this is where we're going to provide a policy in the format of a JSON file here. It's very hard to remember these. So luckily they have a little policy generator down here. I'm going to open it in a new tab. And we're going to drop this down to S3, and we're going to define what kind of access control we want to have. So let's say we wanted to deny anyone being able to upload new files to this bucket. I don't know why you'd want to do that, but maybe there's a use case. So we're going to say deny. We're going to give it a asterisk here, so we can say this applies to everyone. The service is going to be S3, of course, and we're going to look for the actions here. So we're just going to look for the puts. So we'll say put bucket ACL, and there should just be a regular put in here. Oh, that's bucket ACL. We want objects, so we say bucket put object and put object ACL, so we can't upload files, and we'll have to provide the ARN, and they give you a bit of an indicator as to what the format is here. It's going to be exampro -000 / asterisk. So it's going to say any of the files within that bucket, and we're going to go add that statement and generate that policy, and now we have our JSON. Okay, so we'll copy that. I'll go back over here, paste it in, save it, cross our fingers, hope it works, and it has saved. Yeah, so you don't get like a response here. I'm just going to hit save again and then just refresh it to just be 100% sure here, and go back to our bucket policy, and there it persists. So our bucket policy is now in place. So we should not be able to upload new files. So let's go find out if that is actually the case. So here I am in the overview here in Enterprise D, and I want to upload a new file to see this. So let's go to our Enterprise D, and we have a new person here. We have Tomalak. He is a Romulan. And we do not want him in the Enterprise D here. So we're going to drag it over here and see what happens. We're going to hit upload. Okay. And you're going to see that it successfully uploaded. Okay. So we're going to go ahead and do a refresh here and see if it actually is there. And it looked like it worked, but I guess it didn't because we do have that policy there. So there you go. But let's just to be 100% sure that our policy actually is working, because I definitely don't see it there. We're going to go back there and we're just going to remove our policy. Okay, so we're going to go ahead here and just delete the policy, right? It's weird that the interface shows it to you as if, you know, it's actually working. And so Tomalak is definitely not in there, but our policy has been removed. So now if we were to upload it, Tomalak should be able to infiltrate the Enterprise D bucket here. We're going to do an upload here. Okay, let's see if we get a different result. And there it is. So there you go. So our bucket policy was working. You can see that AWS can be a little bit misleading. So you do have to double check things. That happens for me all the time. But there you go. That is how you set bucket policy. So we are on to the S3 cheat sheet. And this is a very long cheat sheet because S3 is so important to the AWS Associate certification. So we need to know the service inside and out. So S3 stands for Simple Storage Service. It's an object-based storage. It allows you to store unlimited amounts of data without worrying of the underlying storage infrastructure. S3 replicates data across at least 3 availability zones to ensure 99.99% availability and 11 nines of durability. Objects contain your data, so you can think of objects like files. Objects can be sized anywhere from 0 bytes to 5 terabytes. I've highlighted 0 bytes in red because most people don't realize they can be 0 bytes in size. Buckets contain objects, and buckets can also contain folders, which can in turn contain objects. And you can also just think of buckets themselves as folders. Buckets names are unique across all AWS accounts, so you can treat them like domain names. So your bucket name has to be unique within the entire world. When you upload a file to S3 successfully, then you'll receive an HTTP 200 code. Lifecycle management feature. So this allows you to move objects between different storage classes, and objects can be deleted automatically based on a schedule. So you'll create lifecycle rules or policies to make that happen. Then you have versioning. So this allows you to have version IDs on your objects. So when you upload a new object, over top of an existing object, the old object will still remain. You can access any previous object based on their version ID. When you delete an object, the previous object will be restored. Once you turn on versioning, it cannot be turned off. It can only be suspended. Then we have MFA delete. So this allows you to enforce all delete operations to require an MFA token in order to delete an object. So you must have versioning turned on to use this. You can only turn on MFA delete from the AWS CLI, and it's really just the root account or the root user who's allowed to delete these objects. All new buckets are private by default. Logging can be turned on a bucket so you can track all the operations performed on objects. Then you have access control, which is configured using either bucket policies or access control lists. So we have bucket policies, which are JSON documents, which let you write complex control access. Then you have ACLs, and they are the legacy method that came before bucket policies. And they're not depreciated, so there's no faux pas in using them, but they're just not used as often anymore. And it allows you to grant access to objects and buckets with simple actions. And so now we're on to the security portion. So security in transit is something you have with S3 because all the files uploaded are done over SSL. And so you have SSE, which stands for server-side encryption, and S3 has 3 options for SSE. We have SSE AES. And so S3 handles the key itself, and it uses AES 256 algorithm as the encryption method. Then you have SSE KMS, and as the name implies, it is using key management service, which is an envelope encryption service. And so AWS manages the key, and so do you. Then you have SSE C, and the C stands for customer. So it's a customer provided key. You actually upload the key. And you have full control of your key, but you also have to manage that key, all right? S3 doesn't come with client-side encryption. It's up to you to encrypt your files locally and then upload them to S3. You could store your client-side key in KMS, so that is an option for you, but it's not that important to actually have here on the cheat sheet. You have also cross-region replication. This allows you to replicate files across regions for greater durability. You must have versioning turned on in the source and destination bucket in order to use cross-region replication. And you can replicate a source bucket to a bucket in another AWS account. Then you have transfer acceleration. This provides fast and secure uploads from anywhere in the world. Data is uploaded via a distinct URL to an edge location, and data is then transported to your S3 bucket via the AWS backbone network, which is super fast. Then you have pre-signed URLs, and this is a URL generated via the AWS CLI or SDK. It provides temporary access to write or download to an object, like data to that actual object via that endpoint. Pre-signed URLs are commonly used to access private objects. And the last thing is our storage classes, and we have 6 different kinds of storage classes, starting with standard, and that's the default one, and it's fast. It has 99.99% availability, 11.9's durability. You access files within the milliseconds, and it replicates your data across at least 3 AZs. Then you have the intelligent tiering storage class, and this uses ML to analyze your object's usage and determine the appropriate storage to help you save money and just move to those other storage classes, which we're covering now. Then you have standard infrequency access, abbreviated to IA. It's just as fast as standard. It's cheaper to access files if you're only accessing files less than once a month, so just one file in the month. If you access it twice, now it's the same cost as standard, and probably a little bit more because there's an additional retrieval fee when you try to grab those files. It is 50% less than standard. The trade-off here is reduced availability. Then you have one zone IA, and as the name implies, it's not replicating across 3 AZs, just at least 3 AZs. It's only in 1 AZ, so it's going to be super fast. And the trade-off here is it's going to be 20% cheaper than standard IA, but now you also have reduced durability, and again, it has a retrieval fee. Then you have Glacier, and Glacier is for long-term cold storage. It's archival storage, and it's very, very, very cheap. The trade-off here is that it's going to take between minutes to hours for you to actually access your files if you need them. Then you have Glacier Deep Archive. It is the cheapest solution or storage class on our list, and you can't access your files for up to 12 hours. So that's how long it's going to take before you can use them. So that is the S3 cheat sheet. It was a very long cheat sheet, but there's a lot of great information here. So yeah. Hey, this is Andrew Brown from Exam Pro, and we are looking at ElastiCache, which is used for managing caching services which either run on Redis or Memcache. So to fully understand what ElastiCache is, we need to answer a couple questions, and that is, what is caching and what is an in-memory data store? So let's start with caching. So caching is the process of storing data in a cache, and a cache is a temporary storage area. So caches are optimized for fast retrieval with the trade-off that data is not durable, okay? And we'll explain what it means when we're saying it's not durable. So now let's talk about in-memory data store, because that is what ElastiCache is. So it's when data is stored in memory. So memory, literally think RAM, because that's what it's going in. And the trade-off is high volatility, okay? So when I say it's very volatile, that means low durability. So what does that mean? It just means the risk of data being lost, okay? Because again, this is a temporary storage area, and the trade-off is we're gonna have fast access to that data, all right? So that is generally what a cache and in-memory data store is. So with ElastiCache, we can deploy, run, and scale popular open source compatible in-memory data stores. One cool feature is that it will frequently identify queries that you use often and will store those in cache, so you get an additional performance boost. One caveat I found out when using this in production for my own use cases is that ElastiCache is only accessible to resources operating in the same VPC. So here I have an EC2 instance. As long as it's in the same VPC, it can connect to ElastiCache. If you're trying to connect something outside of AWS, such as DigitalOcean, that is not possible to connect to that ElastiCache. And if it's outside of this VPC, you're not going to be able to make that connection. Probably through peering or some other efforts you could do that, but generally you want to be using ElastiCache, or the servers that use it, to be in the same VPC. And we said that it runs open source compatible in-memory data stores, and the two options we have here are Memcache and Redis, and we're going to talk about the difference between those two in the next slide here. For ElastiCache, we have two different engines we can launch. We have Memcache and Redis. And there is a difference between these two engines. We don't really need to know in great detail, all the differences, but we do have this nice big chart that shows you that Redis ticks more boxes than Memcache. So you can see that Redis can do snapshots, replication, transactions, pub, sub, and support geospatial support. So you might think that Redis is the clear winner here, but it really comes down to your use case. So Memcache is generally preferred for caching HTML fragments. And Memcache is a simple key value store, and that trade-off there is that even though it's simpler and has less features, it's going to be extremely fast. And then you have Redis on the other side, where it has different kinds of operations that you can do on your data and different data structures that are available to you. It's really good for leaderboards or tracking unread notification, any kind of like real-time cached information that has some logic to it. Redis is going to be your choice there. It's very fast. We could argue to say who is faster than the other, because on the internet, some people say Redis is overtaking Memcache even in the most basic stuff. But generally, for the exam, Memcache is technically or generally considered faster for HTML fragments, okay? But it doesn't really matter, because on the exam, they're not going to really ask you to choose between Memcache and Redis, but you do need to know the difference. So we are on to the ElastiCache cheat sheet. It's a very short cheat sheet, but we got to get through it. So ElastiCache is a managed in-memory caching service. ElastiCache can launch either Memcache or Redis. Memcache is a simple key value store preferred for caching HTML fragments, is arguably faster than Redis. Redis has richer data types and operations, great for leaderboards, geospatial data, or keeping track of unread notifications. A cache is a temporary storage area. Most frequently, identical queries are stored in the cache, and resources only within the same VPC may connect to Elasticache to ensure low latency. So there you go. That's Elastic. Hey, this is Andrew Brown from Exam Pro, and we are looking at AWS Lambda, which lets you run code without provisioning or managing servers, and servers are automatically started and stopped when needed. You can think of AWS Lambdas as serverless functions because that's what they're called, and it's pay per invocation. So as we just said, AWS Lambda is a compute service that lets you run code without provisioning or managing servers. Lambda executes your code only when needed and scales automatically to a few or to 1,000 Lambda functions concurrently in seconds. You pay only for the compute time you consume. There is no charge when your code is not running. So the main highlights is Lambda is cheap, Lambda is serverless, and Lambda scales automatically. Now, in order to use Lambda, you are just uploading your code, and you have up to 7 options that are supported by AWS. So we have Ruby, Python, Java, Go, PowerShell, Node.js, and C#. If you want to use something outside of this list, you can create your own custom runtimes. They're not supported, so AWS support's not going to help you with them, but you can definitely run them on AWS. When we're thinking about how to use AWS Lambda, there is a variety of use cases because Lambda is like glue. It helps you connect different services together. And so I have 2 use cases in front of you here. So the first is processing thumbnails. So imagine you are a web service and users are allowed to upload their profile photo. So what you normally do is you would store that in an S3 bucket. Now you can set event triggers on S3 buckets so that it would go trigger Lambda, and then that image would get pulled from that bucket. And using something like Sharp.js or ImageMagick, you could then take that profile photo and then crop it to a thumbnail and then store it back into the bucket, okay? Another use case would be contact email forms. So and this is the same thing on Exam Pro. If you use their email form, it's exactly this. When you fill in the contact email form, it sends that form data to an API gateway endpoint, which then triggers a Lambda function. And then you have this Lambda function that evaluates whether the form data is valid or not. If it's not valid, it's going to say, hey, you need to make these corrections. Or if it's good, it's going to then create a record in our DynamoDB table, which is the records are called items. And it's also going to send out an email notification to the company so that we know that you've contacted us via SNS. All right. So there you go. So to invoke a Lambda to make it execute, we can either use the AWS SDK or we can trigger it from another AWS service. And we have a big long list here, and this is definitely not the full list. So you can see that we can do API Gateway. We just showed that with the email contact form. If you have IoT devices, you could trigger a Lambda function. Maybe you want your Echo Dot using Alexa skill would trigger Lambda. ALBs, CloudFront, CloudWatch, DynamoDB, Kinesis, S3, SNS, SQS, and I can even think of other ones outside of here like GuardDuty and Config. There's a bunch, okay? So you can see that AWS integrates with a lot of stuff. It also can integrate with third-party AWS partners, and that's powered through Amazon EventBridge, which is just, EventBridge is very mumuch like CloudWatch events. But with some additional functionality there. And you can see we can integrate with Datadog, OneLogin, PagerDuty. So just to give you a scope of the possible triggers available to you. So I just want to touch on Lambda pricing here quickly. So the first million requests, like the first functions you execute, are free per month, okay? So if you're a startup and you're not doing over 1 million requests per month, and a lot aren't, you're basically not paying anything for compute. After that, it's 20 cents per additional million requests, so very, very inexpensive. The other cost to it, besides just how often things are requested, it's also, how long the duration is. So the first 400 gigabytes of seconds is free. Thereafter, it's going to be this very, very small amount for every gigabyte per second, okay? This also is going to, this value is going to change based on the amount of memory you use. I bet you this is for the lowest amount, 128 megabytes. Most of the times, you're not going to see yourself increasing beyond 512. That's really high. But yeah, I always feel that I'm between 128 and 256. Now, just to do a calculation, just to give an idea of total pricing. So let's say we had a Lambda function that's at 128 megabytes. That's the lowest. We have 30 million executions per month. Those are requests. And the duration is 200 milliseconds. For those Lambda functions, we're only paying $5.83. So you can see that Lambda is extremely inexpensive. So I just want to give you a quick tour of the actual AWS Lambda interface, just so you can get an idea how everything works together. So you would choose your runtime. So here we're using Ruby, and then you can upload your code, and you have different ways. You can either edit it in line, so they have like Cloud9 integrated here, so you can just start writing code. If it's too large, then you either have to upload in a zip or provide it via S3. So there are some limitations, and the larger it gets, eventually you'll end up on S3. When you want to import a Lambda. And then you have your triggers, and there's a lot of different triggers, but for this Lambda function, it's using DynamoDB. So when a record is inserted into DynamoDB, it goes to DynamoDB streams, and then it triggers this Lambda function. And then we have on the right-hand side the outputs, and those outputs, it's the Lambda function that actually has to call those services, but you create an IAM role, and whatever you have permissions to, it'll actually show you here on the right-hand side. So here you can see this Lambda is allowed to interact with CloudWatch logs, DynamoDB, and Kinesis Firehose. So there you go. We are looking at defaults and limits for AWS Lambda. It's not all of them, but it's the ones that I think are most important for you to know. So by default, you can only have 1,000 Lambdas running concurrently, okay? So if you want to have more, you'd have to go ask AWS support. It's possible there could be an exam question where it's like, hey, you want to run X amount of Lambdas and they're not running or something. This could be because of that limit. You are able to store temporary files on a Lambda as it's running, and has a limit of up to 500 megabytes. When you create a Lambda, by default, it's going to be running in no VPC. And so sometimes there are services such as RDS where you can only interact with them if you are in the same VPC. So you might actually have to change to a VPC in some use cases. When you do set a Lambda to a VPC, it's going to lose internet access. Not to say that you cannot expose it, because it's in a security group, so there might be some way to do it, but that is a consideration there. You can set the timeout to be a maximum of 15 minutes. So you don't really, if you had to go beyond 15 minutes, then this is where you'd probably want to use Fargate, which is similar to AWS Lambda, but there's a lot more work and setup, and you're charged per second as opposed to milliseconds. But just be aware, if you need anything beyond 15 milliseconds, you're going to want Fargate. And the last thing is memory. So you can set memory. Memory starts at 128 megabytes and goes up all the way to 3008 megabytes. The more megabytes you use, the more expensive it's going to be, paired with how long the duration is. And this goes up in 64 megabyte increments, okay? So there you go. There's the most important defaults and limits. So one of the most important concepts to AWS Lambda is cold starts, because this is one of the negative trade-offs of using serverless functions. AWS has servers pre-configured, so they're just lying around and they're in a turned off state for your runtime environment. So when a Lambda is invoked, these servers need to then be turned on. Your code needs to be copied over. And so during that time, there's going to be a delay when that function will initially run, and that's what we call a cold start. So over here, you can see I have a Lambda function. It gets triggered, and there is no server for it to run on. And so what's going to happen is that server is going to have to start, and we're going to have to copy over that code, and there's going to be a period of delay. Now, if you were to invoke that function again, what's going to happen is, and it has to be recent, right? If the same function, so the code's already there and the server's already running, then you're going to not have that delay. That cold start's not going to be there, and that's when your server's actually warm. All right. So Serverless functions are cheap, but everything comes with a trade-off. And so serverless functions, cold starts can cause delays in the user experience. And this is actually a problem directly for us on Exam Pro, because we didn't use serverless architecture because we wanted everything to be extremely fast, because using other providers, we weren't happy with the delay in experience. Now, there are ways around cold starts, which is called pre-warming. So what you can do is you can invoke a function so that it starts prematurely, so that when someone actually uses it, it's always going to stay warm. Or you can take a Lambda and then give it more responsibility so that more things are passing through it, so it stays warm, more constant. That cold starts is becoming less of a less issue going forward, because cloud providers are trying to find solutions to reduce those times or to mitigate them, but they are still a problem. So just be very aware of this one caveat to serverless functions. So Lambda has something called function versions, and the idea is to allow you to apply versioning to your Lambdas. So imagine you needed to deploy a new version of your Lambda just for beta testing, and you didn't want to affect your production version. You could use versioning for that. Or let's say you wanted to roll back to a previous version, so you had a history of all the changes you made over time. That is another use case for versioning. And so to set up versioning is very easy. All you got to do with your Lambda is publish a new version. Then you're going to name or give a description to that version so we don't forget. There's this thing called $latest, which is always a way of pointing to the latest version of your Lambda. And then you can actually go and look at the history of all your different versions and see when they were published. And then you can see those descriptions. So it makes it really clear, what all those versions do. One thing to point out is that every time you publish a version of a Lambda, it has its own unique ARN, Amazon resource name. So we have version 1, version 2, and then $latest points to the latest version. And the latest version it's not labeled 3, but it technically is version 3. But when you make your next one, that would become 3, and then the one that is current is latest. So one more thing to touch on about function versions is talking about ARNs for Lambda. So when you reference a Lambda, you're using the ARN, which stands for Amazon Resource Name. And a Lambda has two initial versions. We have qualified and unqualified. So what is the difference between these two? It's really the end of the ARN. So here we have $latest. So you see how there's a colon. So that colon could be $latest or :3, which would indicate the version number. And then unqualified is just where you have nothing on the end. So when you are pragmatically referencing your Lambda, so you use an ARN, you can use unqualified, and that always will point to the latest version. But the trade-off is that you cannot use an alias with an unqualified ARN. So that is the drawback there. And you're wondering, well, what is aliases? And that's what we're going to talk about next. So let's talk about aliases. And so aliases allow you to give specific versions a friendlier name when you are accessing that Lambda pragmatically. So the idea is it's right under the publish new version. So you create an alias, then you name the alias that you want it to be. You choose the version, and apparently you can assign it up to actually 2 different versions and then do waiting. So I guess it's kind of a cool way of doing like A to B testing, or like having a production version and then another version. So that would be a great way for that kind of testing. And then if you want to see where that alias is being applied, you go over to just to the aliases tab here, and you can see which versions go to which alias. So Lambda has a functionality called layers, and this is a way of putting additional code and content to include with your Lambda. So the idea is you zip an archive that contains libraries, custom runtime, or other dependencies, and then you can use those libraries in your functions without needing to include them in your deployment package. Why would you want to separate them out from your deployment package? The idea is going to make your package smaller, and if that code is reusable with multiple Lambdas, it just makes it more modular. So there are some limitations with Lambda layers. You can only have 5 layers attached to a function, and all your layers cannot exceed 250 megabytes, and that's when it's unzipped. So the idea is you're going to get something like FFmpeg and put it in a zip. You're going to upload it to Lambda as a layer. So really good use cases could be FFmpeg, NumPy, Pandas, SciPy, Scilern, or maybe PDF Kit, which I didn't list. These are all functions that I've used, and they're actually used on the Exampro platform. And then you attach those layers to your Lambdas. So here we have one called Python Evaluator. So it needs to use all those Python libraries, and it's already set to the maximum of 5. So there you go. That's Lambda layers. We're on to the Lambda cheat sheet. So Lambdas are serverless functions. You upload your code and it runs without you managing or provisioning any servers. Lambda is serverless. You don't need to worry about the underlying architecture. Lambda is a good fit for short-running tasks where you don't need to customize the OS environment. If you need long-running tasks greater than 15 minutes and a custom OS environment, then consider using Fargate. There are 7 runtime language environments officially supported by Lambda. You have Ruby, Python, Java, Node.js, C#, PowerShell, and Go. You pay per invocation, so that's the duration and the amount of memory used, rounded up to the nearest 100 milliseconds, and you're also paid based on the amount of requests. So the first 1 million requests per month are free. You can adjust the duration timeout to be up to 15 minutes and the memory up to 3008 megabytes. You can trigger Lambdas from the SDK or multiple AWS services such as S3, API Gateway, DynamoDB. Lambdas by default run in no VPC. To interact with some services, you need to have your Lambdas in the same VPC. So, in the case of RDS, you'd have to have your Lambda in the same VPC as RDS. Lambdas can scale to 1,000 concurrent functions in a second. 1,000 is the default. If you want to increase this, you have to go make an AWS service limit increase with AWS support. And Lambdas have cold starts. If a function has not been recently executed, there will be a delay. Hey, this is Angie Brown from Exampro, and we are looking at API Gateway, which is a fully managed service to create, publish, maintain, monitor, and secure APIs at any scale. So API Gateway is a solution for creating secure APIs in your cloud environment at any scale. So down below, I have a representation of how API Gateway works. So on the left-hand side, you'd have your usual suspects. You'd have your mobile app, your web app, or even an IoT device, and they would be making HTTP requests to your API, which is generally a URL. And so API Gateway provides you a URL that it generates so that you can do that. And then in API Gateway, you create your endpoints. So here I have endpoints for tasks with different methods. And the idea here is that it's allowing you to create these virtual endpoints so that you can then point them to AWS services. The most common used service is Lambda. But yeah, so the easiest way to think about API Gateway, and this is really AWS's definition, is that the API acts as a front door for applications to access data, business logic, and functionality for back-end services. So it's just a virtual, a bunch of virtual endpoints to connect to AWS services. So let's just talk about some of the key features of API Gateway. So API Gateway handles all tasks involved in accepting and processing up to hundreds of thousands of concurrent API calls, including traffic management, authorization, and monitoring. So it allows you to track and control any usage of your API. You can throttle requests to help prevent attacks. You can expose HTTPS endpoints to define a RESTful API. It is highly scalable, so everything happens automatically and is cost effective. And you can send each API endpoint to a different target and maintain multiple versions of your API. All right, so let's look at how we'd actually configure API and the components involved. So the first most important thing are resources, okay? So resources over here is this / projects. And so, they literally just are URLs. That's what resources are. And in a API Gateway project, you're gonna wanna be creating multiples of these resources, right? Because you're not gonna just have one endpoint. And so here we have / projects, and underneath you can see we have another resource, which is a child of this parent resource, which would create this full URL here for you. You see this weird hyphen ID syntax. That is actually a variable, so that would be replaced with like 3 or 4. But what you need to know is that resources are URLs, and they can have children, okay? Then what you're going to want to do is you're going to want to apply methods to your resources. So methods are your HTTP methods, so it's the usual, right? Delete, patch, post, put, options, head, okay? And you can define multiple resources. So if you wanted to do a get to project's ID, you could do that, and then you could also do a post. And now those are unique endpoints, so both get and post are going to have different functionality. But yeah, you just need to define all that stuff, right? So yeah, a resource can have multiple methods, resources can have children, and et cetera, et cetera. So once we've defined our API using resources and methods, the next thing is to actually get our API published. And in order to do that, you're going to need a bunch of different stages set up. And so stages is just like a way of versioning your API for published versions. And you're normally going to do this based on your environment. So you would have like production, QA for quality assurance, staging. Maybe you'd have one for developers. So you'll create those stages. Now, once you create a stage, you're going to get a unique URL that's automatically generated from AWS. So here I have one, and they call it the invoke URL, and this is the endpoint you're actually going to hit. So you do this like /prod, and then whatever your endpoints are. So we saw in the previous example, we had /tasks and /projects. You just append them there and make the appropriate method, whatever it is, get or post. And that's how you're going to interact with API Gateway. Now, you might look at this and say, I don't really like the look of this URL. I wish I could use a custom one. You can definitely do that in API Gateway. So you could make this like api.exampro.co instead of this big ugly URL. But again, for each staging, they're going to have one. So here it's prod, so there would be one here for QA and staging, all right? And so in order to deploy these versions to these staging, you'd go to your actual API, and you'd have to do deploy API action. Every time you make a change, you have to do deploy API action. It doesn't automatically happen. That's something that confused me for some time, because you think you made this endpoint, why aren't they working? It's generally because you have to do deploy API. So we looked at how to define the API and also how to deploy it. But the last thing is actually, how do we configure those endpoints? So when you select the method for your resource, you're going to choose your integration type. And so we have a bunch of different ones. So we got Lambda, HTTP. You can mock one. You can send it to another AWS service, which this option is very confusing, but it's supposedly there. And you have VPC link. So that would go to your on-premise environment or your local data center or local network, okay? So you do have those integration types. And then once you do that, the options are going to vary, but the most common one is Lambda function. And so what you're going to see is generally this. And the idea is that you get to configure for the request coming in and the response going out, okay? So you could apply authorization. See how it says auth none? So you could make it so they have to authenticate or authorize. And then you can say you have some configuration Lambda, and you have some manipulation on the response going out, okay? So there you go. So get a bit of cost saving here and a bit of less of a burden on your API. What you can do is you can turn on API Gateway Cache, so you can cache the results of common endpoints, okay? So when enabled on a stage, API Gateway caches response from your endpoint for a specific TTL, okay? So that's just a period of time of expiry, right? Or time to live. API Gateway responds to requests by looking up the responses from the cache. So instead of making a request to the endpoint, okay? And the reason you're going to want to do this is going to reduce the number of calls made to your endpoint, which is going to save you money, and it's going to improve latency for the requests made to your API, which is going to lead to a great experience. So definitely you might want to turn on API Gateway cache. So we're going to look at CORS now, and this stands for Cross-Origin Resource Sharing, and this is to address the issue of same origin policy. So same origin policy protects us against XSS attacks, but there are times when we actually do want to access things from another domain name, okay, that's not from our own. And so that's what CORS allows you to do. CORS is kind of like this document or these header files, which say, okay, this domain is okay to run scripts on, okay? And so an API gateway, this is something you're going to be commonly turning on because by default CORS is not enabled. And so you're going to have to enable it for the entire API or particular endpoints, like the CORS that you want to, like the headers you want to be passed along with those endpoints. And so here you'd say, okay, well, posts are allowed, options are allowed, and see where it says access cross origin allow. You're doing a wildcard saying everything's allowed, okay? So that's how you would set it. But just understand what CORS is. And CORS is these headers that say this domain is allowed access to run these things from this location, okay? And so CORS is always enforced by the client, CORS being the browser. Okay, so the core that means that the browser is going to look for CORS, and if it has CORS, then it's going to do something. Okay, so there you go. So there's this common vulnerability called cross-site scripting, XSS attacks. And this is when you have a script which is trying to be executed from another website on your website, and it's for malicious reasons. Because a lot of people, when they're trying to do something malicious, they're not going to be doing it from your site because that's from you. It's going to be from somebody else. So in order to prevent that, by default, web browsers are going to restrict the ability to execute scripts that are cross-site from another site. But in order to allow scripts to be executed, you need a same origin policy, okay? And that's the concept of the browser saying, okay, these scripts are allowed to execute from another website. So again, web browsers do enforce this by default, but if you're using tools such as Postman or curl, they're going to ignore same origin policy. So if you're ever wondering why something's not working cross-site, it's going to likely be this, okay? So we're on to the API Gateway cheat sheet. So API Gateway is a solution for creating secure APIs in your cloud environment at any scale. Create APIs that act as a front door for applications to access data, business logic, or functionality from backend services. API Gateway throttles API endpoints at 10,000 requests per second. We didn't mention that in the core content, but it's definitely an exam question that might come up where they're like, oh, you have something, you're going beyond 10,000 and it's not working. Well, that's the reason why, is that there's a hard limit of 10,000 requests per second. And then you have to ask for a service level increase by AWS support. Stages allow you to have multiple published versions of your API, so prod, stage, and QA. Each stage has an invoke URL, which is the endpoint you use to interact with your API. You can use a custom domain for your invoke URL, so it could be api.exampro.code to be a bit prettier. You need to publish your API via the deploy API action. You choose which stage you want to publish your API, and you have to do this every single time you make a change. It's annoying, but you have to do it. Resources are URLs, so just think /projects. Resources can have child resources. So the child here being -id edit. Hyphen is like a syntax. It's saying this is a custom variable. That could be 3, 4, or 2. It's not an exam question, but it's good for you to know. You define multiple methods on your resources. So you're going to have your get, post, delete, whatever you want. CORS issues are common with API Gateway. CORS can be enabled on all or individual endpoints. Caching improves latency and reduces the amount of calls made to your endpoint. Same origin policies help to prevent XSS attacks. Same origin policies ignore tools like Postman or curl. So same origin policies just don't work with those. Or don't work, but just they ease that so you can work with those tools. CORS is also enforced by the client. Client would be the browser. So CORS, the browser is going to definitely look for CORS headers and interpret them. You can require authorization to your API via AWS Cognito or a custom Lambda. So just so you know, you can protect the calls to API Gateway. Hey, this is Andrew Brown from Exam Pro, and we are looking at step functions which allow you to coordinate multiple AWS services into serverless workflows. Or another way of thinking about it is creating a state machine with microservices. So here we are taking a look at step functions, and the first thing we need to know before understanding it is understanding what a state machine is. So a state machine is an abstract model which decides how one state moves to another based on a series of conditions. So think of a state machine like a flowchart, because that's exactly what it is and what it looks like. And so coming to talking about what is step function. So step function coordinates multiple AWS services into a serverless workflow. It's a graphical console to visualize the components of your application as a series of steps. It automatically triggers and tracks each step retries them when there are errors, so your application executes in the order as expected every time, and it logs the state of each step, so when things go wrong, you can diagnose and debug problems quickly. And so here's an example from step functions where we have this visual workflow here, and you can see there's a bunch of different steps, and it might not be clear what AWS services, underlying AWS services are being used in those steps, but you can code in pretty much a handful of services there, which we'll dig into more right now. All right, before we move on to use cases with step functions, let's talk about the two types of state machines we get to choose from. So when you make a step function, you have to choose a state machine, and we have standard and express. Standard is for general purpose stuff, and express is for streaming data kind of stuff. So looking at standard here, AWS recommends it for durable, checkpointed workflows, for machine learning, order fulfillment, IT, DevOps, automation, ETL jobs, and other long duration workloads, so long workloads. And then looking at Express, and Express just came out, and this is for event-driven workflows for streaming data processing, microservice orchestrations, IoT data ingestion, mobile backends, and short duration, high event rate workloads. And when we get into the follow along, we'll look at these in better comparison, because there is a huge difference between these two here. And they have a nice big chart there when we're creating our step functions. So another thing I want to point out is that you can execute steps in parallel. So if you have a bunch of steps that are dependent on each other before you want it to move to the next step, that is something you can do. So things don't just have to be sequential. And the last thing is that the way you define your steps or your states is through this Amazon States language, which is written in JSON. So you do that visual editor, but you have to go and do this part. And this part is a bit of a pain, but the step functions console does give you a bunch of templates to start off with. So it does ease that pain a bit, but there is that work involved. So now we can move on to use cases. So now we're going to take a look at some use cases for step functions, and these are actually cases that I've used, and it's also convenient that they show up in the AWS documentation, because if you do want to use them, they have all the instructions there. So first we're going to look at manage a batch job or Fargate container. These are technically two different use cases, but they're so darn similar, I group them together. And so on the left-hand side here, we have a state machine defined in step functions, and the idea is that you submit a batch job to AWS Batch. If the job fails or succeeds, it notifies via SNS, and then it ends. Okay, so there isn't a whole lot of logic here, but it's a great way to keep track of the status of a job to see whether it's failed or succeeded. And you can kind of see an idea of where these services are being used. Then you have the case with a Fargate container. So it's pretty much the same process, except now we're replacing AWS Batch with a Fargate container. So run a Fargate task. If the job fails or succeeds, notify via SNS. And we could make this even like a third use case where we replace Fargate with an ECS task. So there's a lot of reusability with this one, and it's very simple. All right, so here's another use case I've actually used on Exam Pro when I had to work with a large record set, and I needed to perform something on each row in the database. So the idea here is you load up a DynamoDB table of all the items you want to perform operations on, and what it's going to do is it's going to pull out each record or row or item, and it's going to perform operations on it. And so the idea is it's going to read a message from DynamoDB, and then we're going to queue up an SQS. So it's going to use first in, first out. So it's going to do each one in order. And as it processes each one, it's going to remove it from the actual DynamoDB table until the entire table is reduced to 0. So that's just another method that you can use step functions for. For step functions, it is really important that you learn the different use cases, and there's a lot of different combinations. So, I definitely encourage you to go and read through all of these so you have more ideas in your mind. And then when you're taking the exam, you can see when step function is a good fit for a scenario, because it does a lot of things. So, here on the step functions use cases, they actually have some nice visual diagrams. So they have one on transcoding media files. So that's a good one. Then they have sequential batch processing. We have one for sending messages from an automated workflow. So there's quite a few here, and you definitely want to go and read through every single one here. Another place is if you go to the documentations, and it's going to repeat some of the things there. Actually, not a lot of repetition now that I'm looking at it. But you can go through here, and this is actually more for implementation. So you can see, and they'll actually give you the example of the state machine code. So, for study, I strongly recommend you read through all these use cases and just look at the syntax here, or just try to go run one yourself. But yeah, just a little add to this section. So we're going to walk through all the different types of states with step functions, starting with pass state. So for pass state, the idea here is that it allows us to pass input and output without performing any work. And these are really useful. So let's take a look at the pass state. And the pass state allows you to pass input to its output without performing any work. So I think of this as a dummy or a mock state, and they're really useful when constructing or debugging state machines. When you look at the example application that is set up for you for step functions when you're first getting started, it's all using pass states. So the idea is we define a type called pass. We can pass it parameters. It's optional, and these are key value pairs, and this is a way of mocking input. Then you have your result, and this is you mocking the task. They call it a virtual task in this case. That's going to be passed on to the next state. And then you have result path, which allows you to manipulate where the result will occur. So if we had an output here, the input was ship, which would get passed along. We have our result from our virtual task called government, and we want to insert it at politics. So that is what the output's going to look like. So that is pass states. So now we're going to take a look at a task state. And this is the most important state for step functions because it's everything that does the work. So for this, there are three types of task states. You have one where it can be performed by a Lambda function. You have the case where you can pass parameters to an API actions to services that are supported with step functions, or you can use something which they call an activity. And we'll drill down into all three, starting with Lambda functions first. So for a Lambda function task, here is an example. And the largest takeaway here is look at the resource. For the resource, we are passing the ARN. And so that's what's going to trigger that Lambda function. And then the result will be whatever's returned from that Lambda. Looking at the next case for supported AWS services that we're accessing via the API, here's an example of a batch job. And you are specifying a resource to the service in the form of an ARN. And then you have parameters, and these parameters are specific to the service. So it's going to vary per service. You have to look them up. That's how that one's going to work. And as far as I can tell, these are the supported services. Maybe there's more, but the documentation wasn't super easy to find on this. But I'm thinking Lambda, Batch, DynamoDB, ECS, SNS, SQS, SageMaker, EMR, and even step functions. And I'm sure they'll keep on adding more. I wouldn't be surprised if Event Bridge is in this list as well. But this list isn't that important because the core ones you need to know is ECS, Fargate, Lambda, and probably Batch. And then the last case for states are activities. These are a little bit more complicated. This allows you to have something doing the work outside of AWS or just hosted somewhere else. So ECS, EC2, ECS, and mobile phones. And I guess the emphasis is really whereas when you looked at the Lambda function for step functions, the task was calling it. It was going to Lambda and say, do this work here, and report back to me. Whereas this one, it waits for someone to pull the actual state of the task to perform something. So to reiterate here, when step functions reaches an activity task state, the workflow waits for an activity worker to pull for a task. So imagine you get to that state and you've set up this activity on an EC2 instance, That's the EC2 instance. This entire time has been polling, waiting for the step function to enter the state. And as soon as it enters that state, then it reports, or it activates its job, and then reports that back, and then the step function moves forward. And here's an example of the code. So this would be the code that you would have to implement on the EC2 instance, the Lambda function, or etc. This is in Ruby. It's obviously in all the SDKs, but you can see you're setting up an activity, and then you have this block of code, activity start. So that starts the polling, and when it actually does poll, the input comes in, and then you're going to output those results, and it's going to get sent back there. So those are your 3 use cases for states, for task states, and they're definitely the most important. Then we're going to take a look here at choice states, and this allows you to add branching logic to your state machine. So here's an example of that logic. The idea is we choose the type as choice, and then we define all our choices and the conditions which will cause it to go to the next step. So in the first case, we have a choice where we say if we have input that's coming in, we have a JSON object, and it has a value of skin, and the skin does not equal pink, then that means it's Andorians, and we will choose that as our next state step. If the next case happens, it could be that we have a variable called hearts, and if this alien has exactly 2 hearts, then it must be a Klingon. We'll move on to the Klingon state. The last one here is a bit more complicated. We have an and, so we're combining 2 statements that have to be true. So if we have an alien that has more than 2 legs, but less than 1 mouth, so 0 mouths, it must be a Tholian, and we can also set a default, and so the default here can be Vulcans. So that is choice state. Then we'll take a look here at the wait state, and this delays the state machine for a specific period of time that you specify. So here's one case where we say wait 10 seconds before moving to the next state, and then there's wait until. So wait until this exact time. And if you're wondering, you do not have to necessarily provide a hard code value. You can pass in a variable using the timestamp path, which will access it from the input. And then we have our succeed state. So this stops an execution successfully. So here is an example. It's very simple. You'd wonder, well, why would you use this when you have the ability to use an end? And it suggested that these are really great for branches that, like when you use the choice, they don't do anything but stop the execution. And saying that something succeeds is very clear. So I think that visually it makes a lot more sense than just to end. So that's the success state. And then we have the fail state. So this is the opposite of a success state, and it marks the end and also a failure of the state machine. So here's an example, but we have extra fields here which success does not have, such as the cause and the error. And this is great for having a little bit more information as to what has occurred. And again, you do not have to provide a next or an end because it just stops the state machine. And then we have parallel states, and this allows us to expect 2 states to be performed, and until they are both performed, not to move forward. So to really make that clear, here's an example where we have 2 states. So I have a lookup address and lookup phone. Until both of these complete, it will not move on to the next step. And this is what it looks like. This one is a little bit more complicated to set up, but the only thing you need to remember is that this is what it does. But you can see on the left-hand side here, we define the parallel, then we define our branches, and we tell where it can start. And we can obviously have even more logic within this, so this can get pretty complex. But yeah, just remember that's what it does here is it waits for both before it moves to the next step. So the last step here is map, and this one's a lot more complicated that I just didn't want to make 5 slides for this, so I figured I'd just open the documentation. But the idea here is that map allows you to iterate over an array. So if we scroll down here as an example, they have a bunch of items in an array. And so this map state allows you to iterate through it, performing that action. So here it could perform this Lambda function on each single one of these values. But you can see it's very complicated in terms of implementation, but just understand that that's what map does. It allows you to do an iterative process, which would be really good for inserting records into a database, which I think is a use case that we show in this section here. Hey, this is Andrew Brown from Exam Pro, and we are looking at the step functions follow along, which to me is one of my most favorite serverless services. It really helps to build out serverless applications. So let's make our way over there. And just before we get going, make sure you are in US East North Virginia. It's very easy to get switched out into Ohio by accident, but this is where we want to be. So we'll go up to services here and type in step functions, which will bring us over to the step function service. We have yet to create one, but what we'll do is go on the left-hand side here and go to state machines, and we'll go ahead and create a new state machine. And scrolling on down here, you can see that we already have some example code. And if you want to generate out code for a variety of things, they have a lot of defaults for us, but we're just going to go ahead and make something from scratch. So I want you to clear this out entirely, hit refresh so we have nothing there, and let's start putting in some of this Amazon States languages. So using empty curlies, the first thing we're going to specify is comments, and I'm going to call this the Star Trek Organizer, Actor Organizer. And you can kind of guess what we're building as we go here. I'll tell you here in a moment, but let's just get through the motions of this. So the first thing is just a comment, and this comment allows us to have a generic description of the state machine. I have no idea where this comment appears, but it's good habits to put it in there, and I think it's optional. The next thing is specifying the version. Right now, there's only one version of the Amazon State language. And if you don't supply it, it is defaulted to 1, but I'm going to put it in there just for fun. The next thing is we'll want a start at, and that is going to define the starting state. We don't have any states yet here, so we'll leave that blank. And then the next thing is we need our states. So yeah, that is the basic setup. If we were to refresh here, we'll get nothing. Let's put a comma here. Okay, we have a start and end. Nothing too exciting. So let's actually get some states in here. And a great way to build out a state machine is to mock out what you want. And through that, through mocking, we can use the type of pass. So I'm going to create a few states here. I'm going to call one called recognize. If I can type that right there, recognize. And then we're going to give it a type of pass. And then it's going to go to the next state. The next state is going to be, we're going to say record state. And the state doesn't exist. I'm not sure why it's complaining. One value must be one of the following recognize. Yeah. And we'll make our first state the recognize state up here. And then we'll go down below. And then we'll make our record state. I'm going to call this recognize state. And then here we will make another state, which will be called record state. And then I'm going to have one final state called success state. And this is just going to be a succeed. I don't think I spelled that right. I think that has 2 C's. We'll do a refresh there. We maybe don't need the comma there. And maybe get rid of the comma there. And so there we have our basic state. So the idea of this little application that I'm building is what we're going to do is we're going to drop an image into an S3 bucket, which is going to trigger a state machine here in step functions. It's going to take that S3 image, send it over to recognition. Recognition is going to give us some data back. We're going to pass that data onto our second Lambda function, which is going to store that into DynamoDB, and we're going to consider that successful. So we'll go down below and hit next. We're going to save our state machine. I'm going to call this Star Trek org. We will scroll down here. We'll let it create new permissions. That seems like a great idea to me. I'm going to hit create state machine. And now we've created our state machine. If we wanted to go execute the state machine, I'm just going to go ahead and hit start execution, and we can just give it any kind of data we want. You can see that it instantly completes because pass automatically passes information to the next step. So we now have that set up there. I do want to add an additional step in here just to make sure this is working. It's going to make debugging a lot easier as well. So what I'm going to do is edit the state machine. I'm going to add an additional state here. I'm going to call it wait 5 seconds state. And we're going to give it a type of wait. And we'll say seconds. We'll say 5. And then for next, it will have to go to this state here. And then we'll just change this one to be that. We'll refresh that. And so we'll just have this additional step. I'm going to put it to 10 seconds because sometimes I like to have a little bit more time there. But that's going to allow us to debug things a little bit easier. Maybe we'll just call it wait state, make it more generic. And I'm going to go, whoops. I'm going to go ahead here and save that. We are going to start this execution here and just see how that looks. So you can see it's waiting here for 10 seconds, and then when 10 seconds occur, it's going to proceed forward. Okay, great. Now that we have this set up, the next thing we need to do is actually create an S3 bucket so that we actually have something to upload images, which will then trigger this state machine. So let's make our way over to S3. You could also use the AWS CLI if you can remember the commands for that. I'm going to make a new bucket here. I'm going to call it Star Trek Org if it's not already taken. And it is, because I've probably done this before. So I'm going to call it Star Trek Andrew Org. And so I have my bucket. Make sure that bucket is in the same region here, US East, so we don't have any issues there. And the next thing we need to do is have some way to upload an image in here, and when that image is uploaded, it will trigger that state machine. So what we'll do is make our way over to EventBridge. And EventBridge is basically the same thing as CloudWatch events. It just was rebranded with some additional features. And we're going to create a new rule here. And I'm going to call this Star Trek Org rule. Now we're going to scroll down here. I'm going to use event pattern. We're going to choose a predefined pattern by service. We're going to choose via AWS. We want this for S3. The type will be object level. It's going to be a specific action only when puts happen. And we're going to specify by bucket name. And I don't remember what the bucket name is called because we had to improvise there. So I'm going to go back here and grab the name. I'm just going to click in here so I can grab it up from here. And what I'll do is go down here, paste in that bucket name. This all looks good. We want to choose the target to be step functions. And we will choose our state machine here. This all looks great. And we're going to hit create. So that looks all great. In order for our bucket or our state machine to actually run a Lambda function, what we're going to have to do is modify our step functions functionality there. So what I want to do is go back to step functions here. And we'll go into Star Trek Org here. And actually, it's a lot easier if we just go to IAM and search it, because it's going to be named step functions anyway if we look for that rule. So I'm going to go to roles here. We're going to type in step functions. And there is our Star Trek one. And notice right away, it has one that says no permissions access policy. And what this does is it denies all access to everything. And the reason it does this is to just have it as a safeguard when you're prototyping your state machine, but we do not need any protection, so we're going to turn that off. And what we're going to want access to is the ability to invoke a Lambda function. I'm not sure if there's a predefined policy, so I'm just going to create one myself. I'm going to call this, we'll name it once we get through here. But what we're going to do is choose Lambda. And the next thing, what we want to do is we only want to be able to invoke. So invoke the function. We will keep it simple and say all resources. We could pick out the step functions here, but I was pasting the ARN in earlier and it was giving me a lot of trouble. So I just want to keep this speedy here. And we'll say invoke policy, maybe Lambda, so we know what it's for. We'll create that policy there. We're going to go back to roles, type in step functions. You can tell I do this all day, every day, because I'm very quick through with IAM here. We're going to type in Lambda here. And we're going to look for our custom one. We can tell it's custom because it doesn't have that little orange box. Orange boxes mean it's managed by AWS. And so now we have that. So we can now execute Lambda functions when we do attach them as, or create them as tasks, state tasks within our step functions. But now I guess the next thing is to just upload an image here and see if it actually triggers the step function. So before we do that, I'm going to go ahead and open up step functions. We'll click into here. And what we're going to be looking for is to see a new action here. We're going to want to click into it as quickly as possible so we can see that it's executing. We're going to go back here. I'm just going to go grab an image. I'll be back in 2 seconds. So we'll go ahead here and upload an image now, and hopefully that triggers. If it's not, we'll go back to EventBridge and give it a nice little inspection there. So I'm going to hit next. We're going to hit upload. That's now uploaded. We're going to go check out our step function, see if it's been triggered, and nothing's happened. So I guess we have to go debug EventBridge there. So just open that in a new tab, and we'll take a peek and see what is what. So I'm going to go to my rules here on the left-hand side. There I have my rule. I'm just going to take a quick peek here. I mean, it looks correct. It says event source S3, put object, Star Trek Andrew org. Star Trek Andrew org. So that seems right to me. So let's go ahead here and edit this and just take a peek. And I'm just going to reset this again. Maybe there was something that we did that made a mistake. Oops. Oh, that looks right to me. So we redefined it there, and maybe that'll make a difference. I'm going to go ahead here and delete this file. We're going to go ahead and re-upload. And so we'll go back to our step functions here. And nothing's triggered. So there is a guide on the AWS docs, and they set up a CloudTrail before they went ahead and set up EventBridge. And I could not understand whether there was a connection to that or not. But it does say here AWS API call via CloudTrail. So maybe we do need to turn on CloudTrail. So what we're going to do is I'm going to go on a whim here. I'm going to go over to CloudTrail. I'm going to make a new trail and see if this fixes the issue. So I'm going to go ahead and on the left-hand side, we're going to trails. I'm going to create a new trail. I'm going to call it the Star Trek org trail. We don't want it applied to all regions. We only need it for US East, and also it's going to save us money. We do not need any managed events because we only care about data events here. We only want to watch it on that specific bucket. So we'll go to the Star Trek org bucket there. We don't need reads, we just need writes. And I would store it probably in the same bucket there. So I'm going to go ahead here and place that in there. And I'm going to go to advanced. Nope, that all looks good to me. I'm going to specify this to be raw. So only look at things that drop into the raw bucket instead of everything within the bucket. We'll go ahead here and create that. So actually we'll just say no here because we want to use the existing bucket here. And, maybe if CloudTrail is tracking it, then CloudWatch event will react to it. But, I thought this wouldn't have been necessary, but, maybe there's just something I'm missing there. So I'm going to go ahead and delete this here. And, we can see we have our AWS logs there. We'll create a new folder called raw. I'll go ahead and upload this here. We'll hit upload. I'm going to go back to my step functions, do a refresh. And look at that. So that's what it needed. It needed that CloudTrail there. So, I guess that was the case. I do want to point out that when we created that CloudTrail, that if we go back, let's just hit create new trail. These data events, you have to watch out because there's additional charges that will be applied for this. This is only a huge issue if you have a large volume of data here. But I think if we were to look at an example, I don't think it's that bad. So if we go down here below, CloudTrail Insights events, that's Insights. If we go to data events, so 10 cents per 100,000 events. So we'd have to upload 100,000 images before we pay 10 cents. And that's why we went through all that effort to really limit what this trail could do, region and the specific folder and stuff to mitigate that kind of problem. But even we're very far away from hitting that and seeing even a charge on our actual credit card with this account. So anyway, now that that's been executing, we'll go back here. And it went all green. If we jumped in here in time, we would have saw that wait state go for 10 seconds. We saw it earlier, so I don't feel that we need to reiterate on that. Let's go ahead here and just remove that wait state because we no longer need it. And let's actually create ourselves a Lambda function. So I'll go here and just put in record. It looks right to me. We'll go ahead and hit save, save. Yep, it's all good. And let's make our way over to Lambda. Now Ruby is my favorite language, so that's what we're going to make it in today. You can do this in whatever language you want, but you're going to have to figure it out on your own. And so I'm going to call this Star Trek org recognize. We're going to use Ruby 2.7. We're going to let it create a new role here. And we're just going to wait a second here as it creates. And then what we're going to do is go down here and we're just going to increase the timeout here to 2 minutes. It shouldn't ever take longer than 10 seconds, but I don't want to have an issue here. All we're going to do is write some code to call the recognition API. And that doesn't requires like the least amount of memory, but it might require a larger timeout based on how fast recognition replies. We're going to go to that IAM role down below and make sure that it has access to recognition. So we're going to go here and type in recognition. We'll give it full access. That sounds good to me. Hit attach policy. And we'll go back here. And then what we'll do is we will implement our function here. So we're going to have to require the AWS SDK for recognition. The nice thing about Ruby is they break up all these libraries into, or like all the AWS APIs into single gems. So it allows us to individually include them, where it's like in Node.js, you just include AWS SDK and it gives you everything. It's not as clean here. I'm just going to double check to make sure I typed that correctly. Looks good to me. And we'll get ahead to implementing this. So first thing we need to do is call the client. Okay, so we'll type recognition client.new. Generally, when you're writing Lambda functions, you want to define your client on the outside, but because of scoping with Ruby, you have to define it on the inside here, but this is Node.js. I'd place that on the outside. Not going to show up in the exam, just good to know as a developer. I'm going to type in client recognition, recognize, and we're going to use this to detect celebrities. And then we're going to just pass some information here. So the first thing is the image, and we can specify an S3 object. If you're wondering how do I know this off the top of my head, it's because I've written it down and I'm looking on it on another screen. And all this stuff shows up in the AWS SDK. So like if you wanted to learn this yourself, you type Ruby SDK version 3. It's good to just show you how I found this information. And I would go into here. On the left-hand side, you'd go down to recognition. If we can find it, there it is. And I click into client. And then here's all the functions. So the one we're doing is called celebrities. We'll go back to here. And see, I spelt it wrong. There it is. So if I click into there, then we get all the information, and it generally tells you how it works. Not all the information, but it's good enough here. And I'm just going to fix that typo there. And I think we called this bucket Andrew. In my case, yours is going to be different. And then we have the name. It's going to be raw TNG crew. It's actually really the key. But for whatever reason, in the API, they call it name. I don't know why. So that is the image part of that. So that is good. And I always like to just comment like this. Makes things a little bit easier to see. Actually, in Ruby, it's a pound. And that is pretty good for a first go at it, because we just want to make sure that this works before we transform the data and do a little bit more with it. But I'm just going to type in here celebrity faces. And we'll just return an empty array here, or curlies. So that looks good to me. And so the next thing is to actually test and make sure this works, and to see if we actually get some data back. So we want to see this puts information. So I'm just going to save this here, and I'm going to go ahead and hit test. I'm just going to type in anything here, test, and create. And then we're going to see if it passes. So I'll have to hit test again maybe. And it failed. Unable to get object metadata from S3. Check object key, region or access key permissions. So this could be an issue if our policy doesn't have access to, oh, you know what? We needed to give this also access to S3. That's the problem here. So we'll go here. Whoa, just double check there. I saw this here. I thought that might have been something else, but it's nothing. I'm going to type in S3 here. We only need read-only access. We're not going to write anything back today. I'm going to save that. And then we'll go back here and we'll test that again. I can't tell if that updated. I'm going to hit that again there. And now it's green. And look, we're getting output. And this is actually showing us information about the celebrity. So we can see some information there. It's filtering out like the type and the name because it's trying to protect that celebrity's information. But if you're wondering like what kind of output we could get the bounding box to their face on the actual image. So that could be a good way to crop out their image or detect them in a photo. We can see some information like, you know, where their eyes are and stuff like that. And so, you know, it also gives us their name and their ID, and I think it gives us a URL to their IMDb page. But we'll make our way back over here, and now that that's working, I just want to massage this so that our data looks a little bit better here. So here you can see the URLs and stuff. I just want their names. So what we'll do is we'll just modify this here. So I'm going to go here, and I'm just going to iterate through this. We're going to say this, call this celeb. And I'm just going to make a new function on top of here called results. And I'm just going to push them here. So we'll say results.push. I'm just going to say name, celeb name. And then we will just do a puts down here and check out the results. I'm going to go to the top here. Just full screen this so it's a little bit easier. I thought I might have had another puts in there. I don't. So we'll see if that is a little bit easier to work with here. I'll go at the top here. Oh, and hit save first. Then we'll go ahead and hit test. And it works. And there we have the names. So that's a little bit easier to work with, I would say. So what we'll do here is I'm just going to pass the results here. I'm going to just call this celebrities. I think I typed that right. And we could just not put returns, but I'm just going to put returns there to be verbose. I'm going to go ahead and save that. So now if we want to hook up this Lambda function to the actual event bridge, what I'm going to do is copy this here. And I'm going to make my way back to event bridge. I guess we closed it, so we'll have to go, or sorry, I keep on saying event bridge. I'm saying step functions. We'll go into our state machine here. We're going to edit our state machine, and I'm going to change this one to task, and I'm going to make the resource here. Oops, actually we need the next state. We'll add another one here called resource, and we'll paste in that ARN. And I'm going to go ahead and save this. Hit refresh first, it's all good. Hit save, save anyway. And so now what I want to happen is when I upload an image, I want it to trigger it. I want to also get through that Lambda function there. So what we'll do is we'll go back to S3. I'm just going to go ahead and delete this image here. And you can use whatever image you want. As long as there's people in it, like celebrities, it'll work out pretty well. And I'm going to use that TNG crew one again here. And we're going to hit upload. And it's been uploaded. We'll go over to our step functions here, hit a refresh. We can see that it's running and it made it all the way through. And what's interesting down here is now we get some information about these lambdas. And here you can get you see the output. So it actually returned this output here. So that means that our Lambda function is integrated. So that's part one of this. The next part that I want to do is I want to make another Lambda, which is going to use DynamoDB and store that in a database. So I guess what we'll need to do is create ourselves a database in DynamoDB. So let's make our way over to DynamoDB. So go up here to the top, type in DynamoDB. Not sure if we already have a database there from prior. Doesn't look like it. We'll go to the tables on the left-hand side, create a new table. I'm going to call this Star Trek org. We don't need anything too complicated here. I guess we're just storing the name and maybe the count. So, and I don't really need a partition key. I'm just going to say name. Maybe we'll do ID and name. So I'm going to go string ID. Sure, we could add a, well, we won't bother with the sort key. We don't need one. I'm going to use the default settings. That seems fine to me. Let me just double check. No secondary indexes, 5 and 5, basic alarms, 80% threshold, encryption at rest. Sounds all great to me. And so now we have a very simple DynamoDB table that's going to spin up here in a moment. So the next thing we need to do is have a way to write this data to our Lambda. So what we'll do is go back here and create a new function. I'm going to call this one Star Trek org record. And we're going to use Ruby once again. 2.7 sounds good to me. And once that is created there, I'm going to scroll down to the bottom here. And what we're going to do is go to role here. And I'm going to attach a policy. We're going to need DynamoDB access. I'm going to go DynamoDB. We'll just give it full access to make our lives a lot easier for this. Generally, you would pare that down to exactly what table you want to use. But we want to make this easy. We'll go back to our function here. And what we'll do is we'll go ahead and write an implementation for DynamoDB. So I honestly can't remember how to set up this call for DynamoDB, but I figured it'd be a great opportunity to walk through how I would go figure that out. So I know I want to write something in DynamoDB, and I'd open up the SDK. I'd look for DynamoDB here, and on the left, and then on the right-hand side, I will click on client. This is only for the Ruby SDK. You always have to click into client. For the other ones, you go on the left-hand side, click into it. You don't have to do anything else. And then we have a bunch of actions here. So what I want to do is I want to write an item. We can do it in batch. Or what we can do is we can write individual items. I think batch is going to be what we want to do because we're going to have a bunch of names and we're going to have those all separate records. So let's open up batch item and take a look here. And I just scroll down here and look for an example. And so here is our example here. I'm going to go over here to this function. And I'm going to pull up my other one as a comparison because generally all the APIs work pretty much the same. So by looking at one and comparing them, we can figure out what we need to do to write it. So I'm going to scroll on down here, and there's definitely going to be some kind of require for DynamoDB. So we'll go back up here. And I think it's DynamoDB. If I don't know, the way we'd figure that out is I would just go and type in AWS SDK S3 GitHub, because these are all hosted on GitHub, right? And I'd go over here to the SDK. This looks like the official one to me. We go into lib, maybe into here. This isn't helping me too much. Here we go. And so I would just search for DynamoDB, and here it's called DynamoDB. Some of these names aren't exactly what you think they would be, so sometimes you have to double check in the case of Ruby. So we'll go back here, and so I have my require up here. The next thing I need to do is actually create the client. So I'm going to need some kind of line like this. And I bet it's DynamoDB. And then from that, we can call our function. So what we'll do is we will go back to the documentation here. And I'm going to grab this write batch item. And we'll get a response. Response is whatever is going to be returned at the bottom here. So down below, this is what we should expect to see. But in any case, we'll just take this one. This one seems okay to me. I'm just going to paste that in there. And I'm just going to give it an empty return here, nothing fancy. And I'm going to puts the response. Puts is the same thing as console log if you're Node.js, or print if you're from Python. But in Ruby, we like to call it puts for some reason. So that should set up the initial thing here. Now we need to figure out what we have to write on the inside. And I'm just going to call this recognition one. I'm just closing it just so we don't get mixed up here. And so there's a couple of things here. We have our request items, our put request, and our put request. So the way it looks like to me is that you have to have one required items. I'm not reading anything. I'm just taking a guess here. And it looks like we need to continuously embed these here. Oh, we have to specify the table name. All right, sounds fine to me. The table name here is called Star Trek org, so we'll supply that there. It is an array, so we'll go here and do that like this. I really don't like 4 tabs, so I'm going to convert this to 2. And I'm just going to fix my indentation here. Otherwise, that's going to drive me crazy. All right, and so we need to request objects in here. So we need 2 put requests. Actually, we just need put. And if we want to do multiple put items, you just repeat it. So what I'll do is I'm just going to copy this here like that. And I'm just going to place this above because I'm going to make this a little bit easier for myself. We know that the event has our data here, so I'm going to do puts event. I'm assuming that it's the same as that celebrities thing that we saw. So we'll do puts celebrities. I cannot type that to save my life. I'm going to make my way back over. Oops. We're going to go back to that Lambda function there, the other one there, and then just go grab that name so it's correct. And while we're there, let's go add the ID because I think the ID is a good thing to add. So we have a little bit more to write to the database. Oh, I clicked into the wrong one here. We want to go to recognize. And we'll just go here and type in ID as well. But I just want to grab that name there because I couldn't remember how to spell that. And so I think that's what we're going to get here. So I'm going to go just event.celebrities here. And what we'll do is we'll just cut it, place it after the client here. And what I'm going to do is map through it. And we'll just say our items here. And we'll say eat or map do. And I'm going to say celeb in here. And then I'm just going to take this, paste that in there. And what map's going to do, it's going to collect them all and then assign them to items. It's just the way Ruby does it. And what I don't know is what I named that column in here. So is it ID? It's capital I, lowercase d. It's important that we match that. Call that ID. And then we'll have name here. And then here, this is where we'll supply those values. So go here to celeb. Using single quotations, we'll do ID. And then for name, we'll do name. And then we'll do a puts here, just to make sure that we've collected that into the correct format. And then we can just pass these items here. So that should do the bulk right there. And now the next thing to see is if it actually works. And I'm just going to hook it up and give it a go. So I'm going to copy this like we did before. We're going to make it back to our step functions. I don't see it open here. We'll just use this tab. Go back to step functions here. We'll go into our Star Trek org. We're going to edit it. We're going to go down to the record here, change it to task, and then we'll type in resource. And we'll put in that ARN, put a comma there, hit refresh, make sure it still works there, hit save. Now the question is this going to work? My feeling is I'm expecting an error to occur. If it works the first time, that is amazing, but we're not always that lucky. So what we'll do is we'll go back to S3. I'm going to delete this photo, and I'm going to re-upload it. Oops, we'll just hit upload here. And then we'll go back to our step function. We'll go back to Star Trek.org, and it's running. Fingers crossed that it works. As you can see, recognition is taking its time. Wow, it went all the way through. Now, this didn't go red, which was where we wrote our write to DynamoDB, but that doesn't necessarily mean that it worked. So we have to double check that. I'm going to scroll down here, and we can see that we're getting some output. We have our recognize state. Let's look at our record state. So at the start of it, it's showing what came into the into as the input, and then this is, I think, the output. The output's here. So I'm not sure what this is, but that's okay. Let me just double check here. I'm just wondering if I removed it. Okay. Now let's go check DynamoDB and see if those records exist. All right, so there are no records. So that was a little bit misleading, right? It looked like it worked, but it actually didn't. But we can definitely see that that these worked. So a way we would go ahead and debug this is we need to go look at the Lambda function in greater detail. I'm going to navigate. I could click through here, but I just want to be very certain that we go to the right place. So I'm going to go back to the Star Trek record here, where we have all this information. I'm going to go up to CloudWatch. It used to be up. Oh, nope. Yeah, it's still up here. Monitoring. Go to View in CloudWatch. We're going to have a bunch of log files here. We're going to look at the last one, and there's only one, so that saves us a lot of trouble. And here we can see that it started and then it ended. So it went really, really fast. So maybe it terminated early and we need more time here. Usually it writes extremely fast, so I'm quite surprised that we don't see anything. So I'm going to just scroll down here. I'm just going to increase the time. And also what I'm going to do, I'll give this 2 minutes. It definitely doesn't need 2 minutes, but we'll just do that for sure. I'm just going to double check to make sure that I copied the right one. Maybe I copied in the wrong file there, or the ARN. Maybe we're doing recognition twice. Nope, it's doing record. Let's double check that there. So we'll go ahead and I guess there's nothing to change here. I'm going to go back to S3 here. We're going to go ahead and delete this file. And we're going to go back and upload it. I'll just hit upload here. I'm going to go back to our step functions. We're going to see that this is running. Okay. We're going to go check DynamoDB. Nothing. We're going to go back here. We'll go back a step here and check the next one. We're getting no logs. Maybe I didn't save this. I'm just going to do a hard refresh here. I'm just going to copy this and then do a hard refresh, because it was showing me the old default information, making me think that maybe I just never pressed that button, which is totally possible because we're whizzing around here. And I feel that that's probably the thing that happened here. So I'm going to go ahead and delete. I'm going to re-upload this, and I bet that's what it was. And I bet we're going to get a failure, and then we'll have to work through that. But this is good because this really gives us good hands-on debugging knowledge of step functions. So we'll go back here, up to here, and we're seeing that it's running now. And look, it's red. So yeah, I just didn't hit save there. We'll go down below and see what the problem is. I don't know if it's going to show us here. Probably not. There is an execution failed here. And we can see that it has a syntax error. Line 16. So we'll go back to here. We'll look at line 16. Definitely there is a syntax error. We do not need a comma there. We do not need a comma there. And we do not need a comma there. So what we'll do is we'll go ahead and save that. And we'll re-trigger that. We'll go back to our S3 and we will hit delete. And we'll go to upload. And we'll go to TNG crew and then upload that. We'll go back to our step function, go back a state here. We'll do a refresh. We'll click into it, and we'll wait to see if it goes red or not. And hopefully it's not another syntax error. And it's red again. And so we scroll to the bottom. We check the execution here. And now it's telling me it's line 26. You got to be giving me a break here. So on line 26, I'm just taking a look here. I made another typo. Okay, bear with me here. We're going to do this one more time. Maybe we should just test this function out. Maybe that would be a better idea. So what I'm going to do is I'm just going to go back to the step function here and then grab the input. I think we just need this here. And we'll go back to this function here. I'm going to make a new test. I'm going to supply that information here. Just put curlies around that so it doesn't complain. Well, it should be fine. What's it saying here? Expected a comma. Oh, there's square braces. That's why. And what we'll do is just call this my test. And I'll hit create. We'll hit save. I don't think we need to save there. And now I'll just hit test. And now we have a failure. Undefined local method or events. So I have another issue here. It's supposed to just be called event. And we will save that again. We'll go ahead and test that again once we close this. Oh, undefined method celebrities for hash. That makes sense because in Ruby, we have to do this. It's not like JavaScript where you can chain them, so that is another issue. So we will save that. We'll go ahead and test that. The provided key element does not match the schema. Okay, now we're getting somewhere. So what it's saying is that this does not match the schema. So just give me a second and I'm going to give it a look. Okay, so I noticed my mistake here. The issue that it's saying here is the provided key element does not match the schema. So I looked here saying, okay, well, something must be wrong here. But the issue is actually with my data. So my test data here, if we look up here in a second, we can see, because I put it, there is no ID. So there's no ID here. And it's not that there is no ID, it's just that I didn't supply any ID information because we pulled from an old test here. But I'm going to go and just edit my test information. And it doesn't really matter what. I just want to put something here. So I'm just going to put 1, 2, 3, 4, 5. And we will go ahead and save that. And we'll close that. And let's give it another test. Oh, and the issue here now is that we said that this would be a string, so we'll just wrap that there. Because I think what will be returned from recognition will be a string. And if it's not, we will convert it to a string. And we'll go ahead and save that, close that, test that. Look at that, finally we are getting somewhere. And now let's go see DynamoDB if it filled them in there. There they are. We'll go ahead and we'll delete all these records. We'll go delete. And now that that's good, let's go see if our function works. And this is all dependent if the ID that is being returned from recognition is a string. And we don't know that. So we'll go back. We'll just close a few of these. I know it's getting a little bit confusing here. And I'm going to go ahead and delete this. There's my delete. We'll go back and upload. Go TNG crew, we'll hit upload, and then we'll make our way back to our step functions, all the way up the top here. We'll check the one that's running. Oh, so close. Okay, what's the problem now? One or more parameter values are invalid, and attribute must not contain an empty string. Okay, so what we'll do is we'll just expand this here. We'll see what it passed through. So it's not passing the ID. So if we go up to our first function here, maybe the output, this is only passing the name. Okay, so what we'll do is we'll just double check the DynamoDB, or not the DynamoDB, but we'll check the recognition API. We'll go to client, because maybe there is no ID and I'm just selecting something that isn't there. Celeb. Recognize celeb. Scroll down here. And there definitely is an ID, and it definitely returns one. So there is something there. So our issue is with our original Lambda that isn't passing anything along. So what we'll do is we'll go back to Lambda. We'll go to recognize. We will scroll on down here. And the ID is here. So it has to be passing it along. What we'll do is I'm going to do a puts here. I'm going to have a puts on the results. I'm going to save this. And this stuff is hard-coded. So we can test this. And now we're having the ID. So this is definitely returning what we want. But I just noticed also that we hard-coded these values. We probably wanted to work on any kind of file. So what we should do is replace this with the data that gets passed along into the event. And I'm pretty sure it's called event. Let me just look this up. I think it's detail. Yeah, detail. And then it's going to be request parameters. So request parameters. And then it's going to be bucket name here. I'm going to extract these out into their own variables here. So I'm going to call this one bucket. I'm going to call this one key, because that's what it should be called. I'm just going to copy that there. And this one should be just key. And then we'll do bucket. And we'll type in key. I'm going to go ahead and save this. But now we actually have to supply these values as such. So what I'm going to do is I'm going to mock this out here. No, I'm not going to mock that out. I know this is going to work. But so what we need to do is we need to just double check here. This orange should be the same. Yeah, it's the same orange, so nothing has changed here. So let's go back to our S3 bucket. We're going to go ahead and delete this file. We're going to upload. I'm going to add this file. I'm going to go to TNG crew. I'm going to hit upload. We're going to make our way back to step functions. We're going to go all the way to the top here. And it immediately fails. And again, this state's doing fine. So recognition's doing great. And that's even with our latest changes. It's still not outputting the ID. It's driving me crazy. All I can think is that this is not right. But it is, because there's nothing else to name it as. So I'm just going to copy this over here. Make our way back to this step function here. Where was it? Here. Paste that in. See, nothing's changed. So there's nothing to change there. Oh no, it's the last one succeeded. Okay, was I just looking at the wrong one? All right, whatever. If it succeeds, that's all I care about. So that makes me happy. Let's take a look here. Yeah, this one has ID and name. And this one's going to say what? It's going to show us what got passed in here. Now let's go check DynamoDB and see if it's there. Fingers crossed. Holy moly, there we go. So we got it working. You can see that doing this is very complex. I could have made a really clean version of this follow along here, but I think it's really important to show you all the debugging processes, because this is the developer associate. And even if I made a really clean version of this, like very likely you would have gotten stuck. So I figured, let's do it this ad hoc way. But yeah, there you go. That is State Machines. This doesn't cost us any money to keep it around. So I'm not going to go through the process of deleting all the resources. Maybe the only one that I would actually consider deleting is DynamoDB, because it does cost something even idle, I think. So if we go here and we go to capacity, Yeah, $2.91 per month. Yeah, I think it's when it's in use. So you could switch it to on demand. Anyway, it's up to you. You can delete your tables and stuff like this. I would say leave all this infrastructure around because I'm going to show you how to use X-Ray to debug this step function. So if we go back to, where the heck is step functions? I've already lost it. Yeah, if we go in here, I feel that we can add X-Ray to both of these, and we're going to get a better visibility. So I think that's what we'll do next. So I'll see you back here, and we'll figure out X-Ray. Okay, so I'm back here, and it looks like we actually do have a service map. I just had to click up here to see that there. So yeah, it looks like we do have a visualization there, and I was just under traces. I don't know, I just thought when I was under here, I should see it here, but this is just the trace map. I'm not using X-Ray on a day-to-day basis, so sorry about that. But now that begs the question, if I move back to step functions, would this work? So that's what I don't know. So I think what I'll do is I'll just unhook this and go back to step functions and see if we actually get some information here. So step function here. We'll want this to be recognized. We will update this. We will go back to our recognize. And this has a destination on it. Maybe I have to refresh here. I might have multiples of this open. We will scroll down. I'm just looking for that one there. Where did you go? It's definitely set here. We definitely have a destination. Huh. Am I just blind or what? Oh, you know what? All we have to do is click here. Wasn't very clear. And we'll go ahead and remove that. And so now that's removed. So it should work just as before. So we'll go back to our step functions. So that's all I want to see is I just want to see a service graph. And what I'm going to do is go back to X-Ray here. I'm going to do refresh. I don't want anything recent, so I'm going to just do that. And what we'll do is we'll go back to S3. We'll delete this file here. We will re-upload that file. And we will make our way back to X-Ray. I'm going to just do a refresh here. If this doesn't work, that's fine. I just want to know, does this work with step functions or not? Because I thought that other thing was saying that it didn't, but it wasn't specifically mentioning service maps. And we'll just double check our step functions to make sure this is working. I think this just happened. Oh, I can't tell now. So we have 2 successes here. I'm just going to do this one more time. And we will go ahead and upload here. No, it's just not triggering. It's not triggering it at all. So that's the issue with our event bridge. So we got to go back to event bridge. And we'll go back to our rules. We'll go back to our rules here. We'll hit edit. I'm just going to re-hook this whole thing up. I don't trust it. And this is not unusual for AWS. Sometimes I just have to do this. And, you know, it's just how it is. A specific operation, we'll type in put. We're going to go down to specified bucket. That is the bucket name. It's set to Lambda still. Okay, I guess I didn't save it maybe. State machines. org update. There we go. And what we'll do is we will go back to our S3 bucket. We will hit delete here. We will go and upload this file here. And we'll go back to step functions. We'll refresh. We can see that it's running, which is great. And, hopefully we reverted it back to what it was before. And that all passed. We'll go back to X-Ray. We'll do a refresh here. And we have no service map information. So I'm going to wait a couple of minutes here. I'm going to come back and we'll see if there is any data, okay? But if there isn't any, then we definitely know. And I guess what we can do is we can tear down this project since we're done with it. So what I'm going to do is make my way over to Lambda. I'm going to go ahead and just delete these functions. So we'll delete that. And I'll delete that one. And then we'll go over to our step functions here. And we'll delete that. And we'll go over to DynamoDB. We'll go to tables, and we will delete that table. And then we will go over to S3. And we will delete this bucket. I do not need this bucket. Sometimes you have to empty them first anymore. I think AWS made it so if you just delete it, it lets you delete. That'd be really nice. Let's find out if that's the case. Beautiful. I remember there was a time where you'd have to go and delete all the files, and they added this empty button, and now you can just delete. So there you go. Everything is teared down, and we are A-OK. So there you go. So we are at the end of the step functions overview. So on to the step functions cheat sheet. So step functions coordinate multiple AWS services into serverless workflows using state machines. A state machine is an abstract model which decides how one state moves to another based on a series of conditions. Think of state machines like a flow chart. Step functions automatically triggers and tracks each step and retries when there are errors, so your application executes in the order as expected every time. Then we have the Amazon state language is how you define all your states and is written in JSON. You should really know how to create step functions, so make sure you spend time doing the follow along. There are two types of state machines available. We have standard for general purpose long workloads, express streaming data, short workloads. There's definitely a bunch of other options, but that is the short of it that you need to know for the exam. Use cases for step functions: manage a batch job, Fargate or ECS container, sequential batch processing, creating a pipeline to transcode media files, transferring data records by performing operations on each record queued up via SQS, sequence steps for ML, steps of ML workloads, coordinate, extract, transform, and load ETL jobs. So if you go check the AWS docs, they have a lot of examples of use cases. You should really know them because you might see some questions that indicate to identify those kind of situations. So let's just break down the types of states for step functions, which makes up everything about making step functions. So we have the pass state. This passes its input to its output without performing work. So I always like to think of it as a dummy or a mock. Passive states are useful when constructing and debugging state machines. Task state represents a single unit of work performed by a state machine. So we have a Lambda, triggers a Lambda function. Then we have activity. The work is performed by a worker that can be hosted on anywhere, such as EC2, ECS mobile phones. And then we have supported AWS services. So we pass parameters to an API of an AWS service, and they take care of the task. Then you have choice states, adds branching logic to a state machine. Wait state delays the state machine from continuing for a specified time. Succeed state stops an execution successfully. Fail state stops the execution of the state machine and marks it as a failure. Parallel states can be used to create parallel branches of an execution in your state machine. The state machine does not move forward until both states are complete. Very important state to know. And the last is map state can be used to run a set of steps for each element of an input array. Really great when you're iterating on a bunch of records in a database. So there you go. That's step functions. So here we're onto the developer associate cheat sheet, and this is just a bunch of loose things that didn't deserve their own cheat sheet, so I just decided to make this all wrapped up in a single cheat sheet. So the first is CodeCommit. So CodeCommit is a service which lets you store your Git repositories in the cloud, and CodeCommit is in scope of many compliance programs such as HIPAA. So the emphasis here is that CodeCommit is really good about security for Git repositories. The next one here is Amazon Certification Manager, which lets you provision, manage, and deploy public and private SSL, TLS certificates for use with AWS services. ACM handles two kinds of certificates. Public certificates provided by ACM, which are free. Private certificates you import, and those are very darn expensive. ACMs can be attached to API Gateway, CloudFront EB, or ELB. ACM is not end-to-end in transit encryption since it terminates before reaching the instance. There might be a way to configure it. I sure don't know how, but generally the way it works is you attach it generally to ELB, and it just is not end-to-end encryption. That's not a big deal. Probably won't show up in the exam, but it's definitely something you should know. Then we're looking at the code development kit, also known as CDK. Write infrastructure as code using imperative paradigm with your favorite language. It's an alternative to CloudFormation, which is declarative, not CDK, which is imperative. All right. Then we have CodeStar. This lets you quickly develop, build, and deploy applications in AWS. It's a wizard for getting common application projects set up. You get a deployment pipeline, access management, and a project dashboard to monitor infrastructure. I'd say it's my least favorite service, but that's just me personally. But it might show up in the exam. Then we have Docker. Docker is not an AWS service, but it's key to containerization. So Docker is a third-party tool designed to make it easier to create, deploy, and run apps by using containers. A Docker file contains all the build instructions to assemble the container image. Then you have Secrets Manager, protect secrets needed to access your applications and services, easily rotate, that's the key word there, rotate, manage and retrieve database credentials, API keys, and secrets throughout their life cycle. Secrets Manager is mostly used to store and automatically rotate database credentials. So we're looking at RDS, Redshift, DocumentDB, and other databases, but they gotta be SQL compatible. And then it can also store key value pairs. So think of it like a hash file. I say hash, that's like Ruby. I guess maybe a JSON file would have been a better description. And so that's the other format it can store. Then you have parameter stores, SSM. SSM stands for Simple Systems Manager, but now we just call it Systems Manager. But anyway, it's parameter stores under that umbrella of services or service. And so it is hierarchical storage for configuration, data management, and secrets management. So it's like Secrets Manager, but it's really just for that key value store kind of thing there. So there you go. That is the loose ends for the Developer Associate, and I hope you pass your exam with flying colors. So here we're onto the Developer Associate cheat sheet, and this is just a bunch of loose things that didn't deserve their own cheat sheet, so I just decided to make this all wrapped up in a single cheat sheet. So the first is CodeCommit. So CodeCommit is a service which lets you store your Git repositories in the cloud, and CodeCommit is in scope of many compliance programs such as HIPAA. So the emphasis here is that CodeCommit is really good about security for Git repositories. The next one here is Amazon Certification Manager, which lets you provision, manage, and deploy public and private SSL, TLS certificates for use with AWS services. ACM handles two kinds of certificates. Public certificates provided by ACM, which are free. Private certificates you import, and those are very darn expensive. ACMs can be attached to API Gateway, CloudFront EB, or ELB. ACM is not end-to-end in transit encryption since it terminates before reaching the instance. There might be a way to configure it. I sure don't know how, but generally the way it works is you attach it generally to ELB, and it just is not end-to-end encryption. That's not a big deal. Probably won't show up in the exam, but it's definitely something you should know. Then we're looking at the code development kit, also known as CDK. Write infrastructure as code using imperative paradigm with your favorite language. It's an alternative to CloudFormation, which is declarative, not CDK, which is imperative. All right. Then we have CodeStar. This lets you quickly develop, build, and deploy applications in AWS. It's a wizard for getting common application projects set up. You get a deployment pipeline, access management, and a project dashboard to monitor infrastructure. I'd say it's my least favorite service, but that's just me personally. But it might show up in the exam. Then we have Docker. Docker is not an AWS service, but it's key to containerization. So Docker is a third-party tool designed to make it easier to create, deploy, and run apps by using containers. A Docker file contains all the build instructions to assemble the container image. Then you have Secrets Manager, protect secrets secrets needed to access your applications and services, easily rotate, that's the key word there, rotate, manage and retrieve database credentials, API keys, and secrets throughout their life cycle. Secrets Manager is mostly used to store and automatically rotate database credentials. So we're looking at RDS, Redshift, DocumentDB, and other databases, but they gotta be SQL compatible. And then it can also store key value pairs. So think of it like a hash file. I say hash, that's like Ruby. I guess maybe a JSON file would have been a better description. And so that's the other format it can store. Then you have parameter stores, SSM. SSM stands for Simple Systems Manager, but now we just call it Systems Manager. But anyway, it's parameter stores under that umbrella of services or service. And so it is hierarchical storage for configuration, data management, and secrets management. So it's like Secrets Manager, but it's really just for that key value store kind of thing there. So there you go. That is the loose ends for the Developer Associate, and I hope you pass your exam with flying colors.